Hello everyone, and welcome to the second edition of the Microservices with Go and real-time distributed systems. And this course has been almost half a year in the making. It has already released on the Self-Made Engineer platform, but as part of my personal agreement of free education on YouTube, I'm giving you guys a good chunk of the start of the course for you to fully enjoy. And if you're new to my channel, I have released last year the first version of this course. It was very well received by you guys, so thank you for that. However, me personally, I was not happy with the quality nor the depth of content that I did. This was, after all, my first big content endeavor. And so I have decided to make this most comprehensive and modern version because, and I say this and it's very important because a lot has changed in the software industry lately. With AI, coding has been easier than before. It has been easier to get started and learning programming. However, that has brought the market industry to be harder to get it. However, I think that most people forget is that the most important part is to learn the computer science, the fundamentals, know the theory instead of just coding and using these tools that can code for you. It is most importantly now to understand how things work, the whys and the hows behind every decision in software, in making software. And so this course embodies exactly that. I start by teaching you the theory. I show you my decision-making process, the pros, the cons of every decision I make. I show you the diagrams, external reading references, and a couple of exercises to challenge you out of your comfort zone. So without further ado, let me actually show you the project that we are going to build, and then I'm going to give you an onboarding or an overview of the curriculum of the whole course. So we're going to build a real-time ride-sharing application very similar to Uber or Bolt. So what we really can do here is that you can either log in as a rider or as a driver. And by the way, this is why we're not going to build on this course. This is part of the starter code project, so you can just install it very easily. I'm going to show you how you can do it. And what we're going to do is that we're going to build the backend of this UI, the whole microservices. So let's log in as a rider. And what you get is that you're going to see the world view of a map of the world. And this is really kind of overkill because we really just want to focus here on the city of San Francisco. So we cannot really go anywhere. What's going to happen once you click on the map is that you're going to be able to preview a trip first. So I can just click on another destination. This is going to preview and the status here are going to update. So let's, for example, schedule a trip to the other side here. And you can see that we're going to be routing for 12 kilometers. It's going to be 17 minutes. And what you're going to do is that you can select the package that you want to ride. So if you're going to ride has an SUV, you can click on an SUV, or has a van or a luxury experience. You can see the price changes according. And the thing is that once you click, this is going to make a request to a pool of drivers, a pool of available drivers that are going to look. There's going to be a service that is going to look for the most suitable driver, and you're going to choose one of them. And you're going to basically send a request to that driver. Hey, do you want to fulfill this trip? Yes or no? So let me actually show you. Okay, so I have just opened on my right screen a new application and I'm going to log in as a driver. I want to be a driver of an SUV, so I'm just going to select SUV. And you can see that here is another view, another part of the application. This is going to be the rider on his car, on his application. And you can see that we have an automatic generated plate of that. But now let's choose an SUV. And you're going to see that with real time, the driver just got plotted the user requested trip. And what we can do is that, hey, a trip has been received. Do you want to do this or not? You can decline the trip. Let's accept the trip. So the trip has started. And what is going to happen is that the user is going to have to pay for the trip. So let's click on pay. And now we're going to be prompted to Stripe UI where you're going to have to pay for our trip. Of course, we're using a test environment for this, so you can really input anything. You don't need a credit card or anything. So let me just hit pay. And now there we go. The trip has been successfully done, it has been paid, and here ends the scheduling flow. So it might look simple, but there's a lot of external service-to-service communication happening here. We are plotting this map, we're communicating with external APIs. So there is really a lot going on, and the goal of this course is to build the backends, the microservices to power this experience. And now more on the technical side, you can actually see that you're going to have kind of a dashboard or a UI with all of the services running, all of the logs being streamed in real time, and you're going to be able to see each individual service. And this tool is called Tilt. This is how we're going to run locally our application running with Kubernetes. And also we're going to have UI for example, to Jaeger. This is going to allow us to see all of the service-to-service communication. So all of the flow that we have just done, it's here. This is called tracing. So you can see that the first request to start the trip actually started on the API gateway, and then there was an external communication to an internal communication to the trip service, and then to the driver service. And this is how we scheduled a trip. So we're going to learn all of this in this course. And then we also have a UI for RabbitMQ, where you're going to be able to see all of the messages, all of the queues. So everything is going to be in detail here. So what is the tech stack for this course and what you can expect to learn by the end of it? So of course, the start of the show is going to be Golang, and you really don't need to know the advanced steps of Go, because I'm gonna teach you that. There's a small module which is the advanced Go essentials, and if you are watching this on a self-made engineer, then you have access to all of the courses and you have access to the advanced Go essentials, and you should start there if you are new, so you have the whole learning path journey for you. And then we're going to move into Kubernetes. This is also going to be very important because we're going to run all of our services inside Kubernetes, and this is a very nice tool to use, which is going to make our lives way easier. And before I go over any of these tools, let me just show you my decision behind choosing these specific tools. And the first was that I wanted to choose in-demand technologies that you can really benefit by adding them to your resume, by learning this. This is going to be a very good use of your time. And so, for example, Go is very high in demand, Kubernetes even more. Kubernetes is usually has very high paying jobs, just like Golang. MongoDB as well, it is on most of full stack positions. Google Cloud, it's more of a competitor to AWS, but the things you're going to learn here are going to be the same if you choose to use another cloud provider. And then you're going to also touch on some TypeScript. You're not going to need to know TypeScript nor write TypeScript. I'm just going to give you the initial template. Starter project is going to have a React TypeScript project, which if you want, you can learn about it and change it afterwards to make it yours. We're going to learn RabbitMQ as well as Docker, which are very in-demand technologies. And the thing is that, for example, RabbitMQ is not that in demand per se, but the idea of a message broker is really in demand for any distributed position out there, for any backend DevOps. You need to know how message brokers work. And the way I'm going to teach you is that I'm going to try to teach you the concepts, the ideas, and then I'm going to teach you the tools in specific so that you can transport this information to any other technologies that you want. So other than that, I have chosen performance tools that are performant for microservices, of course. We want to build a performance application. And so this really is kind of a really good set of technologies for that. And then I also needed to choose easy to medium learning curve to learn technologies. And what this means is that, for example, RabbitMQ is one of the easiest message brokers to learn, unlike Kafka. And so this was really my decision, that I wanted to give a tool that's not that hard for you to get started. And that is why RabbitMQ is here, because you can easily get started with it and then move to any other broker. And then I wanted to also have hard and rewarding when mastered. For example, Kubernetes, it has a medium learning curve, but once you really understand Kubernetes, you really take courses on it to really make the most of it, it is really rewarding and it's going to set you apart. So I wanted to also introduce you to Kubernetes on this course if you're not familiar. And so last but not least, I have already talked about this, but I wanted to make sure that you have tools that look good on your resume for a potential employer. And finally, that it is fun. After all, if you're not making this fun, there is no reason to do this, in my opinion. And just to wrap up, I have already talked some of those technologies, but we're going to use as well Stripe for payments. So we're going to have a module on payments. I'm going to teach you how you can incorporate payments into your application. So if you're building applications, a SaaS or something like that, you really need to know how to incorporate payments into your application, because at the end of the day, you're building software with the idea of selling it. So it really is important to know this. And then we're going to use, in conjunction with Kubernetes, Tilt.dev. This is an emerging tool that I wanted to include, which is part of Docker now. So in the future, you might see this become more famous. So it's kind of an opportunity to learn. And this is going to be how we're going to run our microservices. It's going to be on this UI, on this tool. It's going to be very, very good environment to develop. We're going to see that in the next modules. And so this is Tilt. What's more, we're going to use, of course, Google Cloud to deploy. So we're going to do 2 deploys throughout this course. I'm going to do deploy mid-course so that you can see very fast that you can actually deploy the application at the start. So I'm going to teach you on the Kubernetes module how you can actually deploy it already. And then at the end, we're going to do another deploy, which is going to be the final one. We have TypeScript for the front-end application, which we're going to not work on it, but you can work if you want, but we're just going to use it as a front-end to our backend so that we can have a nice and pretty UI. We're going to use MongoDB at the end of the course for our data storage needs, Jaeger for tracing and observability. So this is a tool that you can use to see the microservice to microservice communication, which is very important. And last but not least, we're going to use the open source routing machine. This is how we're going to handle the networking of the paths, of how we're going to calculate the routing, because we're building a ride sharing application. It's going to have a map, and so we need to plot maps and such routes. And so this is how we're going to use. This is an open source routing machine. You don't need to know anything about this. I'm going to show you that there is servers that you can just consume, external APIs, and then we're going to just get a plot of the shortest path to our destination. So this is interesting if you want to dive more in the course project after watching it. And so just to wrap up, I think this is a really rich set of technologies that are going to really make you a better engineer by the end of this course. Just before we start the course, let me give you an onboarding and an overview of the curriculum that you can expect. So we're going to start here at the Self-Made Engineer. So if you are watching this on Udemy, it's going to be pretty much the same. And so start here on the introduction. There's going to be a couple more videos that you haven't watched this. If you're watching this on YouTube, like how to consume the course here on the platform, because you have the community tab, you have the map, the leaderboards, and I explain you how this stuff works. And then we're going to start with the theory. So microservice architecture design. This is going to be like an hour of me explaining to you why we have chosen microservices, the advantages, disadvantages, all of that. And then we're going to move into setting up our development environment in our machines for both Windows, Mac, Linux. So I explain you for every type of machine you have, operating system. And then very important, I always cover this in my work, it is the clean architecture and the repository pattern. So we're going to have here how we're going to separate everything. And this is really important, an important pattern if you haven't learned already. And then I'm going to cover why Kubernetes, why Tilt. I'm going to show you what would happen if we were not using Tilt or Kubernetes and how cumbersome it would be to develop the whole system. Then we're going to slowly start moving into a distributed systems architecture. We're going to start just with the API gateway. We're going to code our first service. This is going to be very similar to what I teach you here on the backend engineering with Go. So this is that whole course that you might be familiar with, where we build a backend API. However, this is kind of a smaller chunk of it, just this module, because the API gateway is going to be a REST API at the end of the day. And then I teach you WebSockets, because we're going to use WebSockets for the real-time communication. And this is a module on that. Then we're going to move to one of the biggest modules, which is the gRPC, or the service communication with gRPC. This is how we're going to start making our first synchronous communication with our services. We're going to create the trip service. We're going to start creating service-to-service communication, and we're going to use gRPC for that. We're going to also build some of the business logic of our project here. And then we're going to move into the Kubernetes Essentials module. I'm going to teach you Kubernetes. I'm going to show you how it works under the hood. And this is not a complete course. This is kind of showing you the real essentials, what you need to learn without having to take a degree on Kubernetes or something like that. So I really try to focus on the essentials. That's why I called it Essentials. And then we're going to actually do our first deployment to production very early in the course. So this is how you can see that the project is going to be that easy to deploy with Kubernetes. And then we're going to move into the driver service. We're going to do some business work here on this service, and then we're going to finally land into the synchronous communication, which is also a very big module. We're going to set up RabbitMQ, and we're going to get into the world of a synchronous communication. This is a very nice module. I really like how it came out because it doesn't just focus on RabbitMQ, it does focus on these concepts, and then we're going to apply with RabbitMQ for our project. It is a really good module. I really like it. And then we have a module on real-time notifications and how we're going to combine WebSockets and RabbitMQ to achieve the real-time events-driven communication system that we have built on this course. Really nice stuff. And then we're going to start wrapping up with payments. So we're going to create a payment service. We're going to set up Stripe. We're going to set up basically our business here. And then we're going to start getting into this optional module. We're going to set up observability. I'm going to introduce you to distributed tracing with Jaeger, open telemetry. We're going to have reliability. So I'm going to teach you how to make our system even more reliable with dead letter queues, retries. We're going to implement all of that. And I'm going to teach you what that means. We're going to add a data storage to our application with MongoDB. So this is going to be very easy, and it's going to be free to set up MongoDB. And then we're going to finish up with the production deployment, where we're going to send our application to the cloud, which is going to be pretty interesting. And I'm also going to be adding more stuff on this module. I'm going to be updating this course with new lessons as you guys suggest. So this is going to be really a live course, a live project. So this is what you can expect from the microservices with Go. Before trying to understand what a microservice architecture is, we better start understanding where we came from, and that usually is from a monolith architecture. And you are most likely familiar with what a monolith architecture is because it's most code bases out there. It's a single code base that is used for multiple domains or functionality of an application. Take this example. You have here your application, or in this case, you have multiple instances of your application, which is still a monolith. And here you're communicating with an external storage. However, all of your business logic about users creation, user fetching is inside of this application, of this executable. All of your payment logic is inside of the same executable. So if for some reason your payment logic has a bug, everything is going to crash. All of your application, imagine this is a golang application, is going to panic and then is going to throw an error. However, here we are already learning something from microservices, which is redundancy. We have multiple instances of the same executable, which causes our application to be more available. And if for some reason one of them dies, we have another two instances, as well as we have an external storage, which could be one or more instances as well. So it would probably be something like this. And here is already a good case, because what would happen if we had the storage inside of our application? So instead of being a different service, instead of being hosted on a different computer, what would happen if it would be inside of the same application? If the application died, our data storage would also die. So this is basic computer science right here. So the least we can do is offload our data storage outside of the application codes. And just to illustrate my point, this is the simple flow of deployments, of development and deployment of a monolith application. You build it usually into a Docker image, and then you deploy it to a cloud instance or something like that. And at the end of the day, a monolith is just packaged as one Docker image that typically runs on a single or multiple servers. And it's a single unit of deployment where all pieces are in the same code base. This is the most important part. The whole system functionality is deployed as one. And all of this to say that usually the starting point is a monolith project, an old monolith project, which then there is the need, which you're going to get there in a bit, but there is the need to go into a microservice architecture, something like this. But migrating a project from a monolith architecture is usually where a microservice project is born. Microservices are built for scale. Most companies, when starting out, cannot afford or predict that their business is going to grow that much, and they need this highly available distributed system. So usually getting to a microservice architecture is part of a gradual migration process. And in this example, we have here a Kubernetes cluster, which we have multiple services, but imagine that from our monolith application, we actually started migrating one service by a time. So each time that we needed to offload some logic, we created a different service instead of creating this whole thing from scratch. And just like the project for this course is going to be a blank slate, we're going to start from a very simple template, which is already purpose-built to be a microservices architecture. But in the real world, 99% of use cases, you won't create a project from scratch as a microservices. Usually companies can't afford to do that. And it's also not a good idea, as you're going to see in a bit. Now, when should we start a microservice architecture? Usually this is a very hard decision, or it might also be a very easy decision because microservices are very hard and they bring a lot of complexity into a company. So it's very hard to sell a microservice to your employer. And most of the times having a monolith, even if you want to scale, imagine your payment service really needs to scale for some reason. Usually most of the times you can just scale your monolith a couple of times and that will solve it. It's not the best way because you're scaling the payment service as well as you're scaling the whole jungle. But that usually it's not the problem. So I give two cases or two examples. When should we start migrating to a microservice? And that is when part of the system really needs to scale independently, as well as your business is growing and your team is scaling, and you need to divide into smaller teams by domain, where each team is going to be responsible for one or more small services. So here we have the user team, the trip team, and the payments team. These are different services which different teams are working on. And I'm telling you this because you might be in a position, if not now, maybe in the future, that you need to advocate to your employer for an architecture change or something like that. So it's important to understand that usually a microservices change to your architecture comes from business needs as well as technical needs. And when I say business, it's usually organization. So there's more people because we need to move faster. However, more people cannot work on one code base because they're going to go into each other's toes. So it's a wise idea to split them up into smaller services or smaller teams. As well, I want to give you this article from Martin Fowler, which he explains a very interesting pattern, which is the Stranger fig, something like the analogy of this tree. And this is one of the best practices that you can use to migrate from a monolith into a microservice. I've done and I've seen this in production many times, and it's a very gradual process. And this is a very good article that you can read if you want. By now, you might be thinking that monoliths suck, and whenever you hear monolith, you mean legacy code, inefficient, and that is completely wrong. That's not the idea I want to give you. That's exactly why I started the course with this video, a separate video for this. It's because most of the times you can fix your problems, your scalability issues by just scaling one monolith into multiple instances. But when that's not enough, we come to microservices. So let's just wrap everything up and see some of the advantages and disadvantages of monoliths and microservices as we start migrating into microservices. So monoliths are simple to develop and deploy. So we have one code base. It's very easy to deploy. We have more code reusability because we have everything on the same folders, on the same code base. And then it makes it very easy to debug. This is one of the biggest advantages of microservices is due to the distributed nature, it's going to be harder to debug them. But monolith also have disadvantages. The first one is scalability. As we have talked about, it's harder to scale a monolith without scaling the whole thing. Then it has some conflicts for bigger teams. As your team starts scaling and your business is growing, it's harder to put everyone working on the same code base. And there is the resistance to new technologies. So if you want to add REST, because REST is faster for some things, Go is faster for other things, there is the challenge to add multiple technologies in the same code base. That's usually very hard. And if you have legacy code, good luck, because you're going to probably have legacy code without a major refactor to everything. However, on microservices, we have the distributed architecture, which most advantages from microservices actually come from being a distributed, from the distributed nature of it. Then we also have team autonomy, so multiple teams can work on different services. They have better context, they are more efficient. Microservices are more robust, which means that if one service goes down, another one can quickly replace it. Just like the monolith, if the application dies, we can quickly replace it. However, on the microservice architecture, we have more granularity, because if one of the services dies, the application still works, and we can quickly replace this service with another one because service is smaller, and we can just fix it and not deploy the whole system, the whole jungle. And this is what I also mean by targeted scaling. Then we know that we have separation of concerns, we have multiple services. And finally, I've been mentioning a lot teams working on services, so organizational efficiency, because in my opinion, this is a big requirement for me. It allows organizations to delegate work and separate big teams into smaller ones. And this is just the natural evolution phase from a startup into a bigger scale up. And just like anything in software engineering, microservices have disadvantages and some big disadvantages, if I must say. The first one is increased complexity. Just like this course, it's going to be more complex because we're going to work on multiple services at the same time. Although we're going to work on just one code base for simplicity, because we're just going to be one developer, it's easier to work on one code base. Usually microservices are separate code bases. Not always the case though, but it might be. Then we have higher costs of running, means more services. Kubernetes is expensive, all of that's going to be more operational costs. And then we are going to have more security challenges. We have more services, we have more points of failure, latency issues. Usually services communicate with other services, so they need to communicate some way. This introduces latency, of course. And then testing, end-to-end testing is going to be especially hard on microservice architecture. And just to sum it all up, I want to mention that you don't win by having microservices. You don't win by having microservices. This is not a thing, okay? There is no right or wrong architecture. There is only the right for the right context or the right problem. And the best two reasons to choose microservices, again, I'm just reiterating what we have just said, is that your organization is growing and you need to allow more developers to work, or technically, you need to improve scalability and resilience of your system. These are the two main reasons to go to microservices, which at the end allows more independent teams, more productivity, and more and faster release cycles. Now, just because this is a course about microservices, I didn't want to bring these topics up because I'm just one person. You're probably just going to be working at your project. And the reason that you might be learning this is because you need this for work at the company you're at, or you're looking to land a new job, or you're just doing this for fun or adding to your portfolio. So of course, we're not a big team. We don't want to hire more developers. However, we want to learn these principles so that later on in the future, they are useful. When thinking of designing with microservices, we need to shift our thinking from traditional systems. So instead of thinking of the system as a whole, we need to think of the system as the sum of its parts. And those parts are the most basic unit, the service. And so, if we understand what a good service is, then we are halfway there, because the other part is knowing how to communicate with one another. And this is where the next lesson comes in, the communication styles. But for now, let's focus on defining what a good service is. And the first thing is that it should be micro. As the name implies, the service should be small, a focused component that addresses one specific task or one business domain. And it does it exceptionally well, just like the Unix philosophy. And it also needs to be autonomous. Each service should be independently deployable, and it should also operate on its own. As well, as we're going to see in a bit, it needs to be loosely coupled. And this is very important. We're going to have a couple of minutes just dedicated to understanding what is coupling and cohesion. So we need to aim to reduce the interdependencies between services. So what this means in theory is that, or in practice, is that services need to know as little as possible about each other. Very important. And for example, if you are a front-end engineer and you are used to building front-end applications, for example, with React or Svelte, you are already accustomed to the idea of making your components dumb. So the idea of making dumb components. And this is the same philosophy because it allows you to kind of piece together in many ways possible. And so I always like to give this analogy for those of you that come from front-end. Then a good service should also be context bound, which means that it's capable of being developed by a small team, essential for high productivity by avoiding high communication overhead of large teams. We have already covered this on the last lesson. So let's explore more the idea of cohesion and coupling, because I see a lot of people talking about this idea. However, not everyone explains in detail what this means, and so I want to give some time to explain to you. This does not translate directly to microservices. This is more into good code practices, but it, as you're going to see, having good code practices also relates to having a good microservice architecture. Everything is kind of related to each other. You're going to see it's pretty neat. Let's actually start with coupling, because it's going to make it easier for you to understand, I think. So the first thing is that by the end of this, we want to have in our head that we want to achieve high cohesion and low coupling. So keep this in mind, as you're going to see in a bit. Now, regarding coupling, coupling describes how much one module relies on other modules. This is not a definition, but this is like my take on what coupling is. So the whole point of a microservices is to be able to make a change to one service without needing to make a change to another service. This is where coupling comes into microservices. For example, we want loosely coupled services, which know as little as they need to know about the services it works with. Take this example that I wrote here. Imagine that we have a payment processor that needs to send notifications after processing payments. For example, this is our initial use case. This is, for example, a module in your code, a package, or something like that. It could also be a service which has two other services dependencies, or you might think this is a function that is dependent on these two other modules. For example, the payment processor here, as I mentioned, needs to send notifications after processing the payments. As well, it also needs to create reports, for example. And what would happen if we wanted to make changes to the payment processor algorithm? At the end, what would happen is that we would make indirect changes to the reporter and to the notifier, because they are all together in the same function, in the same code. And this is what I commented here. So changes to the payment processor would create changes to the reporter and notifier. Let's contrast this to the other idea of where we have low coupling. So I wrote down below that instead of directly embedding the notification, let's, for example, use the notifier as a service, as a separate dependency. So in this case, if changes occur in a notification service, like switching email provider or updating the algorithm, you would only need to update that service, leaving the payment processor unaffected. For example, in this case, here the payment processor is injected by two dependencies. And here you can have, for example, inversion of dependencies or the repository pattern, something that we're going to take a look into how we're going to organize our codes in the next module. It's going to be pretty interesting as well. So you are already getting the basis to have a good service architecture as well as good code composition. So here you have the overall picture of the contrasts between a high coupling and a low coupling, small example. Now, before moving to the cohesion, let me actually show you what this means in practice. So some types of coupling. In the microservice architecture, one of the types of coupling is called the domain coupling. And this is the example. We have a trip service, and we also have a driver and a payment service. But to complete a trip, for the trip to be completed, we need to call the driver service to find a driver, as well as we need to take a payment on that payment service. And this is what it means to have a trip completed. And as you can see for this example, the trip is interacting with other domains and it is coupled to the driver as well as it is coupled to the payment in order to have a trip completed. It cannot do the trip creation alone. And this is kind of a good coupling, as I wrote here some notes. On a microservice architecture, this type of coupling is unavoidable. There's no way around this, and the only thing we need to take in consideration is to minimize the amount of coupling that we need, which means to avoid creating more services than you really need. And I really emphasize on creating the minimum amount of services. Because at the end of the day, interaction between multiple domains, multiple services, it's normal. This is how to produce an output on a microservices architecture, okay? So don't worry too much about domain coupling. It's normal, it's unavoidable. However, try to minimize the communication as possible. Now I just want to show you another type of coupling, which is actually combined into two. It's the common and the content coupling. In this example, we have what most people would consider normal, which is two services, and they are sharing the same database. For a smaller project, this is not a problem, but once you go to production, once you have multiple teams, multiple people, a lot of clients, this is really a problem because writing and reading to the same data, for example, to the same row on a table, this can cause conflicts, data races, all of that, which can still happen on just one service communicating to the database. However, once you have multiple services, changes to a DB schema, for example, you're going to add a new table, you're going to change the user table, all of these changes needs to be replicated and updated on these services. Now imagine that you have 4 services, 5 services. This is really an overhead to add changes to your code base. And so this is kind of an anti-pattern, if you will. And it also kind of defeats the purpose of targeting scaling, because imagine that the trip service is going to scale to 10 instances, and all of these instances are going to use the same Postgres instance that the 5 servers of driver service is using. So you can see that this poor Postgres database is going to be even more bombarded. So this is all I wanted to show you about coupling. Don't worry too much if this didn't make super sense, if you don't have these ideas on your head right now. They will come to you, believe it or not. Now let's take a look at cohesion. It's very similar to coupling, so it has some similarities. However, when we talk about cohesion, we need to strike a fine balance. I'm going to show you what this means in a bit. But cohesion is how closely the responsibilities within a single module or service are related. So in the case of microservices, we want to make it as easy as it is to change. So we want functionality grouped together in such a way that making changes in fewer places is desirable. So if we change behavior on one service, we want to change it and then deploy it immediately without having to change any other services. So this is very similar to what we talked about here. So we can see the changes that we did to the database are going to have to be made on the other services. This is what I mean as well by having low cohesion. Now let's consider that we have this example. We have a create strip function that not only creates strips, but it also calculates the routes, fares, and finds the driver. Ideally, and in theory, this is low cohesion. However, when I mentioned that we need to strike a fine balance, this is what I meant. Let's take a look at this. So we're going to create in the course a function like this, which it is going to create a trip, it is going to find routes, calculate fares, and it's going to find a driver. Now here you could offload all of this functionality to different services. You could have a route service. You could have, for example, a fare service and then a driver service. This would be, in theory, the ideal scenario. However, as you're going to see, this adds a bit more complexity to our code base because now we have the routing service, which you need to maintain and develop, and then we have the fare service that we need to also develop. And I know by fact that these services are going to be very small. So we need to compromise a bit. And in this case, it's not that we're going to have that much low cohesion. It's not a bad cohesion. What you're going to end up doing in practice in the course, kind of deleted everything, is that we're going to have the routing and the calculation of fares in the trip service. So it's grouped together. It makes sense. It's inside of our domain of trips. However, when we talk about finding a driver, it completely makes sense to go into an outside service to get it. So some notes I wrote here is that we need to change, if we need to change something, we want to do it in fewer places possible. This is the essence of cohesion. So if we have to touch on a lot of services, we have to do a lot of deploys, making changes harder. This is also the other part that I mentioned about having a lot of services to do something which in theory is correct. So we need to find boundaries that help us place the related behavior or code together. So with all of this said, some of these principles are very hard to follow, and even on this project, we're not going to 100% have loose coupling. We're going to have some coupling. We're going to create fewer services so that we can strike balance in between what we can develop and what we can do ourselves. And this is in order to decrease complexity of the system. So because of the nature of this project and because we're going to be a solo developer, we need to take these concepts with a grain of salt, okay? So this is not like a holy grail that you always need to achieve. It's good to keep in mind, but you also need to think of the other side of the coin about adding more complexity than you need. What I usually recommend is to start simple and only then add complexity and refactor once we need. And just to leave this lesson with a gift for you, I'm going to recommend you this whole website, honestly. It's the Microservices.io. I'm going to leave this resource as always below, but this here is the holy grail if you want to dive into the theory behind organizing and designing microservices. It's a very good, and if you just search on microservices on the Google, you're probably going to land on this article here, on these websites. So now that we know what a good service is and how to define it, let's focus on this lesson on how do these services communicate. Because this is the other side of the coin, which is how do these services, these isolated services, communicate with one another. And here there's two main big ways of communication. There's the synchronous communication, and then there's the asynchronous communication. These are very different in a way because one of them is blocking, which means that when a service makes a call to another service, it blocks the operation while waiting for a response. So for example, if service 1 makes a call to service 2, he is going to wait until service 2 processes and then returns the response. So here, service 1 is going to have to wait, and then the user that made the request is going to have to wait for this. This is not bad per se. It is good for the workflow that it's is good for, if that makes sense. And then we have asynchronous, which on the other side, if the service 1 makes a request to service 2, he is not going to wait. So he's going to send an event, for example. We're going to see this here on the PubSub and as well as on message brokers. Service 1 can continue doing whatever he needs to do. And then whenever service 2 completes his task, he's going to, for example, notify service 1 that it's complete. So this is a bit of an example of the two differences. You could, for example, think of asynchronous like Go routines. Go routines are non-blocking. They don't block the thread. So we can continue your program while a Go routine is running. So just another example. And throughout this course, we're going to focus on multiple communication styles. We're going to start with HTTP and the REST. So we're going to build a small HTTP to HTTP communication. And then we're going to also take a look at gRPC. After that, we're going to focus on a more asynchronous or event-driven architecture. We're going to start with message brokers. We're going to use RabbitMQ. And I also added this note that Kafka, for example, is another popular alternative. As long as it fulfills the event-driven architecture, it is asynchronous. And finally, I've also added PubSub. Although PubSub, we're not going to use it per se. We're going to use some of its ideas on message brokers, because we're going to use queues and topics, and then publishers are going to publish messages and subscribers are going to react to this. So I also added PubSub because in other projects, it's very common to see. And just before I show you practical examples, take a look at how would the coupling from the last lesson be on these two communication styles. How would the coupling be on synchronous against asynchronous? Think for this for a bit. Consider on the left the synchronous one. We have a service one that is making a call to another service or multiple services you could add. But here there's a tight coupling between one and another, because on this side, the service 1 is waiting for a response on service 2. And if service 2 is slow or is even down, the caller, the service 1, is going to be affected. And these can lead to issues like cascading failures. But on the other end, we have here, for example, service 1 and service 2, just to continue this same example. These services can somewhat operate independently, and I say somewhat because, as you saw, creating, for example, a trip is not just one service. Even if another service is down, we still need for all of the service to work. But in theory, they operate independently, and the requester isn't blocked if the service to, for example, takes more time than it should or is down. And in the larger picture of things, this actually improves resilience and scalability, since the system can absorb a higher load and service interruptions and all of that. So this is where microservices shine, because of the asynchronous nature of the communication. Hopefully that made sense to you. If not, we're going to explore some concepts here. So some practical examples that I have drawn here. So we're going to use this hybrid approach a lot. This is pretty much actually the approach that they're going to use throughout the course. We're not just going to stick to one, of course. Both have their pros and cons, and we're going to utilize that. And here is the essence of this architecture. So we're going to have an API gateway, which is going to be one of the services, and the asynchronous workloads are going to be our backend. So all of the other services are going to communicate with one another through a synchronous nature. However, when the user makes a request and expects a response, we're going to have the other side of the synchronous nature. So the gateway can handle synchronous requests from the clients. In this case, it makes sense because the user might be waiting for a response. However, we are going to delegate the backend work to the asynchronous backend services. So for example, here a user makes a trip through an HTTP request or a WebSocket. We're going to actually use both. And then we are going to communicate with the gateway. Then the gateway is going to communicate via gRPC through the other services. And each service is going to have its own gRPC server, or at least the servers that are going to have gRPC. They are going to act as a server, whilst the gateway is going to act as a client, and they're going to exchange request-response style of communication. Then once we need to share information between services to services, we're going to use asynchronous messages. So for example, we're going to use the pub sub pattern where we're going to publish a message to a queue, and then we're going to respond or react to a message from that queue through another service that is listening for that specific message. For example, if we create a trip, we might just send a message that a trip has been created, and then the driver service is going to start working and finding a suitable driver for that trip. And then once the driver is found, we might send another message that we want to look for, let's say, a payment. We want to generate a payment link, which then we're going to send to the user for him to pay the trip. So this is the essence of the hybrid approach, because this combines the responsiveness of synchronous calls with the decoupling benefits of an asynchronous communication style. And another quick example I want to show you is Gateway has an orchestrator. I have a note here that I'm going to show you in a bit, but focus now on what is here. So the user makes a request to the gateway. For example, that same example, let's create a trip. First, the gateway is going to get a driver manually. So we could just use gRPC with the request response blocking nature. So let's get a driver, let's wait, then let's get a trip. Once you get a trip, let's actually compose the trip and the driver data in one response and send it to the client. Why I'm showing you this? Because I think this is somewhat fine in some cases. However, I think as well that this approach is a bit of an anti-pattern. Some books and articles out there say that this is an anti-pattern, and it's actually true for some examples. And the reason is that the gateway here has to wait for the response and then call another service, wait for the response, and use the output from one as the input to another one. And for this style or for this communication pattern, it's useful sometimes, but I would advise you to use it with care, because I think the main drawback that people mention is that the response time for the user might be bigger, or this kind of defeats the architecture for microservices. I tend to agree and disagree, so I'm just showing you that this exists and that you can use it as well. So yeah. So to finish all up, let's look into more details on these separate styles of communication. So here we have HTTP. We're very familiar with this, or at least we should. And for HTTP, I also added REST, which adds a key concept, which is the resource. For example, when you make requests using HTTP, sometimes you use the REST principles, which add a couple of ideas. And here we have the resource, which is the trips. And then here is the resource ID. We also use methods, for example, get, post. Get is usually for retrieval, post is for creation, delete is for deleting, put is for updating or other actions. And then another thing is that when working with APIs via HTTP or REST APIs, usually there's no strict contract, unlike what we're going to see on gRPC. So the documentation is usually loosely defined. You could say that, for example, having a Swagger documentation is not, but I think it's still loosely defined. There's no like strict contract you actually need to follow. If the documentation changes, you're not going to have an error. So I kind of based on that. And then usually messages are shared via text-based, so JSON, XML. So looking at gRPC, we have a bit of a difference here where we have higher performance because this framework, instead of using text-based, it uses protocol buffers, which is a binary format. Then, as I mentioned before, we define services messages into schemas. These schemas are usually .proto files, as we're going to see in this course. And the code is afterwards generated on both the server and the clients, which makes it very awesome because we don't have to rely on loosely defined documentations. If this file changes, we're going to generate new code and we're going to need to update the client and the service because our code is going to throw an error. And it is nice for service-to-service communication. And then I just want to also mention that this supports simple request-to-response communication as well as streaming RPCs, and this is a bit of an asynchronous nature style. And so gRPC makes communication strongly typed and contract first, which is awesome for internal service-to-service communication, when, like I mentioned. So when should we use HTTP or when should we use gRPC? So HTTP is excellent for public-facing APIs and scenarios where interoperability and ease of debugging are prioritized. So if you have a client that requires to consume your business application, it's very easy to export your application as an API because most software out there communicates this way. So this is kind of a standard, and you're not going to expose your API as a gRPC for at least for a general purpose API. And then because the nature of request response, everything on that side is very easy to debug because request response, you can just console log it or log the output from the response and of that flow. Then on the other side, we have gRPC, where it's well suited for high performance internal service to service communication, where strong contracts and efficiency are critical. Now, both of these communication tools are still synchronous though. So this is where we're going to transition into asynchronous, and I'm going to do a kind of a slow transition to show you where they excel. And we have already talked about this. I'm just showing you visually to help you retain this information. So the synchronous messaging pattern, request response. So if service A communication to service B fails, we kind of arrive at the problem here and how can we fix this? Let's take a look on the asynchronous messaging pattern, where instead of having a direct communication, we're going to use a highly available middleman. And this is very important because this is kind of the keyword for solving this problem. Because this middleman, the message broker or the queue, this is where we're going to send messages. And that broker, that technology, is going to handle how to deliver these messages and how to deliver to the right destination. This is pretty important because if the system is down, it's the job of this middleman to make sure that these messages are stored, they are delivered to the right service, and all of that is important to have a highly available service. Looking at this example, service A does not care about whomever is going to listen for his messages, just like service B doesn't care whomever is going to send them. He just cares about the messages that he is interested on. So listening for a message and when available. So when the message is available, we're going to react to that. And then this middleman just needs to make sure that he does his job well by being highly available, and then he can do all of that I mentioned here. Okay, so this is the nature of an asynchronous or asynchronous messaging pattern. Why is this better? I've added here some text that you can pause and see, but I'm just going to iterate it for you so it makes it more loose coupled. So service A and service B do not directly depend on each other's availability. It's more scalable because messages queue up in the broker. Service B can scale indefinitely, and then we can handle a burst of messages as well. So if there's 1,000 messages, we can scale 1,000 instances and handle those messages gracefully. It's more reliable and fault tolerant because if service B goes down, the broker can hold these messages until service B is back up again. And finally, it's more durable because properly configured brokers like RabbitMQ or Kafka, they support message persistence and acknowledgements. We're going to take a look at this in that chapter, which can prevent message loss. So again, like what I mentioned, if the service, even the broker goes down, we can still prevent that those messages are going to be lost. And so this is everything I wanted to teach you on this lesson. The biggest takeaway is that there's multiple communication styles, there's multiple ways of communicating between service or system to system. I just want you to be aware of this. We're going to touch on all of this, so hopefully this was insightful to you. Now that you know how to define good services and how to make them communicate with one another, let's finish everything up on this module by defining the system as a whole. So let's start by defining what is the business problem even. So we want to allow users to schedule a ride or a trip to a destination via certified drivers. So just by reading what is the problem, you can start thinking and understanding what kind of domains, what kind of services we are going to touch or create throughout this journey. Now, the thing is, this usually involves numerous and often tricky trade-offs, and there is no right or wrongs when defining the services or defining a microservice architecture. There are multiple ways to solve the same problem, and we will use this time to define the services. You probably are already familiar with them because I have been using examples of these services throughout my explanations. We also should use this time to define the tools. However, we have already done that before, so we're just going to focus on the process of defining the services. So this is really the essence for this final step, is identifying the services, defining their responsibilities, how will they collaborate with one another, choosing the right technical architecture, deployment strategy, message broker, all of that. But all of that is easy, and it's not as important as defining good boundaries for our services. Because if we don't take the time now to define the boundaries for our services, later on we're going to regret that. And of course, this is a project course. I need to maintain a balance of simplicity and value that you're going to learn from. So I've taken some decisions here, which I'm going to show you the process. And then I'm going to link you to an article, which I think it's very interesting if you are in the process of defining a microservices project for your business or the company where you're working at. So the process usually is, it's pretty simple. You don't need to overcomplicate this, but it's just identifying the core business functions. So what we saw here, just by reading the problem, you could identify what were the domains and the functions that we need to achieve. So what we want to achieve is this trip schedule flow. This is the whole functionality of our application. And we should also maybe think about scalability. Not going to touch much on this right now, but it should be part of the process. So here are the three services, or you could include API gateway as well. I'm not going to touch more on the API gateway because we have already had a dedicated lesson for it. But these main services are the ones that I have ended up defining. We could create more, but later, more on that later. So the first one is the driver service, which I have added here a note. So we're not going to have the concept of users, which in this case are the riders, the people scheduling the trip, as we are going to be the riders, which are going to schedule a trip. And this is just for simplicity. So we could, in theory, create a new service called rider service. And what this would do is very similar to the driver. It would basically match you to a driver and also store your user profile, everything, all your trips and everything. And we're doing this again for simplicity because all we care about is the trip creation flow. And so we're going to use the trip service as a way to store the drivers. Not only that, but it's going to also handle matchmaking. So basically, you're going to match a driver to a trip. So what this means is that I have taken down one service, which was the users or the rider service, so that we can just focus on riders. This means that you're not going to store the riders for our application. If you want, later on, when you finish the course, you can of course expand it, add your services. However, as I'm recording, I need to keep the services somewhat low so that there's less room for error on your side as well. Then the most important service is going to be the trip service. This is the middle of everything. It's going to have the most code. And this is basically very straightforward. It's going to handle trips, but it's going to also handle a couple more things. Routes and fare calculation. Basically the price, the distance calculation of your journey. And finally, we're going to have the payment service. At the end of the course, we're going to add the payment flow, and this is going to be pretty simple service. Then here is just a quick overview of the service responsibilities. It's important that we type them so that we have reference. This is just a high overview, of course. So we store and handle driver matching for a trip for the driver. We also notify drivers that the trip is available. So the matchmaking system that I mentioned, it's going to be a very simplistic flow. But you could expand very easily the algorithm for this on the distance. If the user is very far from you, you don't want to select the driver that is very far. You just want to use a radius or something like that. We're not going to create any algorithm for this. Later on, if we see fit, we're going to do it, but we're just going to use a simplistic flow to have the system working because this kind of starts getting away off the course. But this is what I mean by the matchmaking. So you could add your own algorithm if you want. Then the trip service is going to handle the CRUDs, the create, read, update, deletes for trips, route calculation, fares. Payment service is going to handle payments, and we're going to use Stripe for that. And by the way, this is the article I was mentioning about. I'm going to leave the link, as always, below that you can read. This is about an assemblage. It's called the introducing assemblage, a microservice architecture definition process. So it's basically a process to define your microservices in a more of a detailed way, you could say. Now, regarding the communication styles, as you have seen before, we're going to use HTTP with a small REST API for communication with the outside of the microservices. We're going to use gRPC to communicate service to service, basically delegating the work. And finally, we're going to use message brokers for the asynchronous part, where we have decoupled and async communication between services. And we're also going to use this for commands and events. More on this on the next slide I'm going to show you. So here is a simpler diagram flow of the trip creation flow. You can have access to this code. This is on the code base. If you go to documentation, architecture, you're going to have the trip creation flow version 0 and the version 1, which I'm going to show you after this one. It's a bit more complex. I just want to show you this simpler way first. If you haven't got the code base access yet, just watch this video. Then on the next module, I'm going to show you how you can have access to the code base. And then if you want to visualize this diagram, you can just copy that code and paste it here on the diagram. So what I do is that I also have an extension for VS Code, which I can see here, or you can just copy everything except these lines here. So you can just copy the sequence diagram and then just paste it here, and you can see that the diagram is going to show on this tool. It's called the Mermaid Lev Editor, and this is called that Mermaid language, basically. It's a way for you to write code which is going to show a diagram, basically. It's kind of a new tool to me as well, so I'm experimenting on this course with it. So the flow is the following. The user is going to create a trip, so it's going to issue an HTTP request to the trip service, which is going to emit an event, and then the driver service is going to listen for this event, and then it's going to find a driver. Once it finds a driver, it's going to issue a command to the driver, so the user application, and then the driver is going to either accept or reject by sending a command. Then the driver service is going to basically emit another event saying that the driver has been assigned, and then the trip service is going to finally listen for this event and is going to return the trip created. Now, looking at the more complex version of this diagram, this is the more accurate to what we're going to do. Don't get scared by this flow, because we're going to do this step by step, and there is a lot of detail as well on this diagram, so that's why. So again, here we have a user issuing a trip request to the API gateway this time, but we're starting by previewing the trip first, and then we're going to have a separate flow for the trip creation. So first we're going to issue a request for previewing the routes and seeing the calculation, the pricing, and all of that, and then the user can agree or disagree with that trip. So after that, we're going to do a gRPC call with the preview trip to the trip service. Trip service is going to call an external API called the OSRM API, which is going to basically calculate the route in the real world map and get the distance pricing of that for us. This is going to be HTTP. After that, the trip service is going to return this to the user, which is going to display a visual UI as we have seen on the introduction on the map with the route. If the user wants to continue this trip, he can issue another request to create the trip this time, which is going to go to gRPC, going to go to the trip service, which you're going to emit that event that you already saw to the driver service. The driver is going to issue a request to the driver, to the user driver. He's going to accept it via WebSocket. So here we have the WebSocket connection. So this is going to be real time. So we're going to use WebSocket communication for that. Then This command is forward to the API gateway, which you're going to basically send this message to the right user, to the right driver that we're going to that he's going to listen on the WebSocket. So we need to have a connection there. And then once the driver accepts, we're going to update the trip. The driver is going to be updated on the trip status. We're going to update it on the database. And finally, once the driver is assigned, we're going to emit a new event, which this time the payment service is going to listen. He's going to create a checkout session, and the session then is going to be sent to the UI, which we're going to show the payment UI. All of this is using a WebSocket hook. And then the payment flow is pretty straightforward. Once we communicate with Stripe, Stripe is going to send a webhook payment success. And then finally, the trip is going to be considered finished once the user pays the trip. And so basically, this is the whole flow that we're going to create throughout this course. So on this video, I'm going to show you guys all of the tools you need to install before we start working on the project. And this video is catered for those working on a Mac or Linux. The process is going to be very similar, but if you are on Windows, I've made a separate video for you to watch. Basically, this is going to be very straightforward. We're going to install just a couple of tools. If you want to follow along on the text guide, if you go to the starter project, and by the way, all of the links should be on the description or wherever you're watching this. And the first one is on Mac. We need to install Homebrew. So this is like a package manager, and we're just going to use Homebrew to install Go. If you already have Go installed, you can skip this. Then we need Docker for desktop and Minikube and all of that. And I'm going to go straight to Tilt, because Tilt is the tool that is going to help us run Kubernetes locally. It's going to make our lives way easier. And the reason that we need all those tools, and you probably already have Docker. I mean, if you're watching a Microservices course, you most likely already have at least Docker installed on your Mac or on your Linux. But if you don't have, go to Docker for desktop, download it. I'm on Mac, Apple Silicon, so I have an M1 chip, so I didn't install this version. And after that, you can just continue. The next thing we need is to either enable Kubernetes on Docker for desktop. And what I mean by that is that if you go to your Docker settings, so if after it is installed, you click on settings, or you can go here to this gear icon. If you click here on Kubernetes, you can enable this. And by the way, this is optional. If you don't have this enabled, you don't need to enable. I'm just showing you because you might have already used Kubernetes before, and that is completely fine to use the Docker for desktop Kubernetes cluster. However, I'm going to show you how to install using Minikube. That's how I'm going to run throughout the course. So you don't need to install, you don't need to enable this, okay? So the next step is to actually install Minikube if you are following along. And Minikube is just like that option I showed you. It's a local Kubernetes cluster that it can allows us to run a lightweight version of a Kubernetes cluster on our machine. If you just open up this website or just click the link on the documentation, it should be already pre-selected what are your configuration. For me, it is correct, but double check on your side as well. After that, you can just hit copy and let's paste it in. I think I already have Minikube installed, but either way, I'm going to follow along. Then all we need to do is just run Minikube start. So if this is your first time, this might take a couple of minutes, 5 minutes, 10 minutes, depending on your machine. It's going to download some extra packages, and after that, it's going to boot up a new container that you can already see here. This is the Minikube container. So if you restart your machine, I think it should start Minikube by default. I usually don't shut down my machine. I just leave it on sleep. But most of the time, whenever you work on this project, you need to boot up Docker, of course, and you also need to make sure that Minikube is started. If not, you can just run this command again, okay? And how do you know that you have your Minikube configured and all of that? Run this command, and it should show some pods. Okay, so if this works, your Minikube installation is correct. or you can also use the kube control and see what is your context. So I'm using kube control or kubectl config get context. And this is going to print the current context has Minikube. If you're using Docker for desktop, it's going to show you Docker desktop or something like that. And yeah, if this command works and you have here Minikube, you're all set. I think kubectl should be installed with Minikube by default. Still, if you don't have kubectl or kube control installed on your machine, I'm going to leave this link below that you can install it manually. So you can see that you have the macOS and it's really straightforward as well. Just make sure that you have Apple Silicon if you are on Apple Silicon selected. Okay, after that you can just install Tilt. So let me just copy this command here and then let's paste it on the terminal. So there you go, Tilt is installed. And I think if you are installing this on Mac, it should already be added to the path. So you can see Tilt is, it is added. What you can do now is you can just run your projects with Tilt up. Currently, I don't have the project installed. So let me go to the self-made engineer code repo. And what you can do to get started, on the next video, I'm gonna explain the folder structure and all of that in more detail. But now let's just clone this to our machine. What you can do is you click on this, use this template. It's gonna create a new repository on your account, and then you can just clone it to your machine. What I'm gonna do instead is that I'm just gonna clone it, because this is just to show you how to run the project easily. So I'm gonna do a git clone. After that, you can just go to the cd microservices, and then we're gonna have this file called tilt file, and this is what we're gonna use to run our projects. We're gonna change this file in the future, add new services, all of that. This is a configuration file, but we're gonna touch this in more detail in the videos to come. What you can just do to test if everything is correctly installed is run tilt up. This should be the only thing you need to run throughout the course. You don't need to install anything else because everything is installed for you now. All you need to make sure is that Docker is running and you have a Kubernetes cluster running. For us, that is Minikube. Now, what you can do is either open up this link, or you can just hit spacebar on your keyboard, and this should show the Tilt UI. You can also use a visual terminal alternative as well, if you click on the stream logs, but I like to use this UI, it's pretty neat. You can see what's going on. If you click on detail, you can see that everything is green except the web. This is the front-end application using Next.js. It's basically booting up. It takes a while if it's your first time, so you don't need any knowledge of front-end TypeScript. Everything is bundled for you on a Docker container using Tilt. All you need to do to see if it is working is wait for the starting and the ready. Then you can click on, let me actually open up this on the browser. It's not showing. I need to click on web, then click here on localhost 3000, and you can see that the application opens up fine. And if you reach this point, it pretty much means that you have the correct installation. Right now it doesn't do anything because we still need to code the backend. Right, so in this video, I'm going to show you everything that you need to install for running this course and the project on Windows. And just to preface, I'm not a Windows user, so my knowledge of Windows is actually pretty limited. But what I'm going to do is that I'm going to give you two options to follow along. If you are already familiar with developing on Windows, and I mean, this is an advanced course, so you should already have most of these tools installed and have a development environment of your own. But if you don't have, I'm going to walk you through everything either way. So the first option is to install everything through PowerShell. So Windows has the PowerShell, which is what comes with Windows. You can install everything there. But because I'm going to run on Mac throughout this course, I'm going to record as my development environment machine. I'm going to recommend you to install Windows subsystem for Linux, or WSL, which basically emulates a Linux distro on your Windows. I think this is the recommended way of developing on Windows either way for this course or not. So To install it, you just do WSL install on PowerShell. So you can just open PowerShell, copy this command, paste it, and this is going to install a lot of stuff. You can install Ubuntu from default, and then you can just type WSL, open it up, and then you're going to have this terminal, which is different, and you need to make sure that you have your this prefix here basically with your root user, and all of that basically means you are on a Windows, on the Linux system. Okay, if you don't want to do this, it's fine. You can just go through PowerShell. All of the tools have that option, but I'm not going to be able to provide you that much support because I don't usually use this Windows computer. I just got access to it to record this video for you to help you along the way. Okay, so the first thing is that we want to install Tilt by the end of this video, because this is how we're gonna run our projects. This is how we're gonna compose our development environment for Kubernetes locally. It's a pretty neat tool. I'm gonna explain to you better Tilt along the course, but to run Tilt, we need a couple of tools. The first is that we need Kubernetes, and we need Docker for that. So we can download Docker for Windows if you don't have already. So just come here and then download Docker for Windows. Okay. Once you have that, you need to restart your machine. All of that, you're going to be prompted to create an account, and all of that, you can just skip that as of now, and then just double click on Docker for desktop. And once you get to this UI, basically you have Docker installed on your computer. Just make sure to open settings. And then there's an option called WSL2 or something like that. This one here, for me, it's disabled. If it's not enabled for you, just make sure that this is checked. I'm not sure why this is disabled, but that's at least checked. And then go to your WSL and do Docker PS, for example. If it doesn't throw an error, it means that Docker is installed on your Linux subsystem for Windows. And that is important. If you get any error, by the way, on the project README file, so here is the source code or the starter for the project. This is what you're going to download in a bit. You're going to have on the README file all of the instructions to install everything on your machine. But if you have any error installing Docker, I'm going to leave this link here from the official Docker documentation on some steps to install Docker on the WSL. And here they mention pretty much everything step by step. Once you have Docker installed, the second step is Minikube. I'm going to say that this is optional because you can have a Kubernetes engine with your Docker for desktop. If you come here to settings and open Kubernetes, you can enable this. But throughout the course on my machine, I have used Minikube to run and develop on a local Kubernetes cluster on my machine. This is what I have used throughout the course, and I'm going to show you how you can also do this on Windows. Okay, so click on Linux because right now we're going to install on your WSL. Then select your architecture. Most likely it's this one. Then just click copy, and for this you need to make sure that you already have Docker installed. Then just paste this in. It's gonna download Minikube, and now let's run Minikube start. This is the second step of the process. This is going to start the cluster. I'm not sure if I'm gonna get an error because I already have this installed. And then by the end it's going to create a container on your Docker for desktop, which once you open, you can actually already see it here. So it's already doing stuff. It's creating this container with your Kubernetes cluster. Okay, so it seems that it has installed. This might take a while because it's going to install some stuff on your machine. Then you can just continue this installation. Here I'm going to leave out this link, but I think this is optional. You can just run this Minikube dashboard just to show you that it actually comes up with a nice UI for you to see throughout the course. If you want to use this UI, you can just type Minikube dashboards, and then you can see all of the resources on your browser. Let me just wait for this to open. And it seems that it didn't automatically open, so I just click this link, and here you can see that you have this Kubernetes UI, which is pretty neat. Okay, so let's continue on. We have Minikube installed. If you just do Docker PS, you can already see here the Minikube. Let's clear this. Now, the last two things to install, and I'm assuming that you already have Go installed on your machine. If not, I'm going to show you as well, because it's part of the steps. It's install Go. But let's first install Tilt. So right now, let's go back here to the Linux, because that's what we're going to do. Let's just copy this script here, because I think we already have kubectl, because it comes up with minikube. Let me just see. If it doesn't, you can click that link and install it. Yeah, it seems we do, because if we run kubectl or kube control, we can see the default engine is minikube. So if you see the kube control config current context, the context is going to be minikube. So if you're going to the minikube route, you should have minikube printed here. If you're going to the Docker desktop, you should probably have something different. I'm not sure what it is. But now let's install Tilt. Don't forget to run all of these commands on your WSL. Make sure that you're not on PowerShell and you are on WSL. Then you can just run Tilt version. I think for me it works because I have already added to the path, but here you can see that you can also add it to the path, or you can run this program. WSL has admin. Run this command again, and I think they are gonna add it for you without you manually adding. But if you have Tilt version working, then everything is installed correctly. The last thing is Go. We need to have golang installed. Copy the link I have left on the project README here to install Go. After that, you should have Go installed. And actually, for my surprise, I don't have Go installed. So let me quickly install it. So to install Go, I'm going to run this command. You can just copy it from the documentation, from the README on the starter templates. Let's just hit enter. Let's then run the second command. I already typed it before, so let me just do it again to show you. And then the final thing that we need to do is add Go to our path, because if you just type Go right now, nothing is going to work because it's not on the path. To do that, let's start by running the third command on the documentation, this one. Then let's open the current directory using the Explorer. So let me just hit enter, and here you should have the .bashrc file. I think you should have this one even if it's a fresh installation. If not, you can always create one. But what I want to do is open this file. I don't have VS Code installed on this computer, so I'm just gonna open up with Notepad. And then all I'm going to do is that I'm going to scroll down below. I'm going to add some new lines, and I'm going to copy the codes that I have added there on the description on the README file. And then I'm just going to save this. So if I save, close, and then I'm going to hit bash to reload my my terminal. Then I'm going to hit go, and you can see that Go is correctly installed and added to the path. Okay, so now that we have Go installed, we have all the tools installed, we can start using the project. So go to the self-made engineer codes to the Microservices Go started, or just click the link below. What you can do is use this template, which is going to basically create your repository on Git. It's going to do all of that. What I'm going to do, just to simplicity reasons, is just I'm going to clone it. You can also do this if you want. Then you can just do git clone. And the good thing about using the WSL is that Git is already installed. So if I just run this, it's going to work because we have Git. Also, let me see if we have make installed. We actually have make, so, or we don't. So make is one of the tools, because if you look at this code, we have a make file, and since we're here, we can just install make. So let me just run these commands. This is so that we can install or that we can run commands using the make. This is a tool that I think it comes with Linux, so I'm actually not sure why it's not here, but if I just run make now, you can see that it works. So the first thing is that let's go to the Microservices with Go project. And here, all we need to do is open up on VS Code or whatever you have, but I'm just gonna do Tilt. And this is gonna boot up Tilt. If you just hit space, or in this case, I'm getting this error because I don't have my default browser on path. You can just click this link and it's going to open up the Tilt UI. So this is something we're going to see a lot, and everything is green, everything is good. If you get some error like Go is not installed or something like that, you can just follow along on fixing that, or just let me know on how I can help you. But right now what's going to happen is that the project is booting up the front end. It takes a while because it's TypeScript, if you know what I mean. But the API gateway with Go is already booted up. It's already working. Let me actually increase here the fonts a little bit. So let me just wait for the project to compile. It seems that it's done. We can just click here on localhost 3000 and the project is running on Windows easily. So this is actually the first time I have installed this on Windows. So you can see that it worked for me. So it should probably work for you as well. And with that, we are ready to continue with the course. So hopefully right now you have your project cloned on your machine. If you don't, you can always get it here from the template. As I have mentioned before, what I recommend is to click on these use template. You can create a new repository automatically on your profile and then just clone it from there. So you're gonna have an instance of this template on your machine. And after that, you can just open up on your code editor of choice. But on this lesson, I'm going to give you a quick onboarding on what the current code base looks like and how it's going to evolve throughout this course. And then on the next lesson, it's actually a pretty important one because I'm going to distill some of the theory behind the way I like to organize my services independently on how you structure your code. So it doesn't matter however you're going to organize your codes, your folders, because those ideas are the basic principles that you can use to structure any Go project or any project on any language, honestly. And it's based on ideas like the clean architecture or the hexagonal architecture. I don't usually like to mention or rely on those ideas because they change with time. However, what I'm going to do is that I'm going to distill a step lower so that you can actually understand the principles and the ideas behind those ideas, and you can just apply it on your own or even read more technical documents from there. Now, looking at the folders, you can see that the first two don't matter here. This basically is VS Code configuration. It's what I'm using. And then I have a build folder. This is a temporary folder with the binaries installed because I have already done the tilt up. This is how you start your project. Just run tilt up. So you should have already watched the previous videos where we installed the tools needed to run the project. Here we have just some documentation. I'm going to update this along the course with the documentation files you need. So all of the documentation is code. You can see here that we have the trip flow, for example. What this means, this is a mermaid flow. This is a diagram language that you can just use to see these diagrams. What I have is I have an extension here on my VS Code called Markdown Preview Mermaid. This allows you to see these diagrams on VS Code, or you can just open this on your browser. I'm going to show you this once we get to there. But if you just click here on the preview, you can see here the diagram in codes. This means that the diagram that I show you throughout the course is going to be on text and it's going to be on Git. So if any change I make to this, you can have the most recent version and you can have the diagram on your side instead of just drawing something on the diagram. So the most important diagrams are going to be here. Then we have the infra folder. This is a very important folder because it contains all of the infrastructure for the multiple environments. For example, here on the developments, we have the Docker files. So we have the Docker for the gateway, and we also have the Docker for the web folder. And then here we have a .bat file. This is just if you are running on Windows to help you out building the project. I'm going to explain to you in detail what this means, but you can see that the Docker file is a bit different than usual. This means that this is going to be used for auto reloading on local developments because we're going to be using Tilt. I'll get that into a bit. And then we have the Kubernetes folder, just short for Kate or Kubernetes. This is how you usually seen written online, because we are developers and developers are lazy. Here you have some files and configuration for Kubernetes. We're going to take a look into more detail into all of these. So we can just close this for now. We have the same setup for production. It's not the same setup because here we have actually different Docker files. These actually builds for production, so we're not going to be running on a development environment. This is going to push our code into a Docker file and we're going to run on the clouds. We're going to deploy very early this project so that you can see that it's completely production ready out of the gate. Okay, if you have any other environment that you want to add, you can add here a staging or something like that, a testing environment. You can just add them here. Then the most important one is the services. This is where all of the services code is going to live, and I have just here the API gateway. This is just starter code that you can use to boot up our project. And you can already see something interesting here is that you're using a package called ride sharing. This is the name of the project. You can see here on the go.mod, and you can see a lot of packages already installed here. And this is something very important because in this course, I decided to install everything from the get-go so that you don't have to pause the video, install something, have issues. If the project works now, if you can just do tilt up and it's going to boot up your project, most likely you don't need to install anything throughout the course. The only thing you need to make sure is don't run go mods tidy, because what's going to happen is that everything is going to go because we're not using any of these dependencies right now. So just make sure that you don't run that, because you're going to have your dependencies to disappear. But this is pretty much all we're going to use. You can see that we have Jaeger for observability, we have gRPC, protobuf, so a lot of stuff that we're going to cover throughout the course. Now going back to the main.go file on the API gateway, you can see that we have this shared package, and this here is a common directory for reusable code or reusable packages that we're going to use across all of the services. So most services are going to listen or fetch environment variables. So one of the packages I have included is this small library to fetch environment variables depending on the type. So this is a very common code that I write on all of my projects using Go. So I have just included this here, and any code that you have that multiple services are going to consume, you can just drop them here into a package, and then you don't need to copy and paste around, because each service should be his own service. It should not know about the existence of other services. However, this shared package is like a common repository of where you can import reusable codes. One of which is going to be the contracts. The contracts is pretty important because this has some types already filled in. For example, if you go here to the WebSocket or ws.go, you can see that we have here some types already pre-filled. And the reasoning for this, so that we have a common interface to use throughout all of the services. Not only that, but because this project already has a front end built into it, we need to have some common grounds between the front ends and the back end so that there is no types mismatch throughout the course. So this is one of the reasons we have already some types. For example, the web service message, this is going to be the interface or the blueprint to send any message between the backend and the front end with a WebSocket message. So this needs to obey this type. The front end is expecting a type of this signature. The same happens for HTTP. So this is going to be the HTTP response, HTTP error, and the AMQP protocol messages are also here. So these are all of the events that we're going to create, and the events are here so that we don't create any typos throughout the course, so you can just have a better experience following the course from your ends. And then I have here some folders which are empty. For example, the proto, I can actually just delete this because we're not going to use that for now. That was because I have run the make file I'm going to show you in a bit. But right now we don't have any proto definition, so that is not going to be used. Then I have here a small retry package that we're going to use, so nothing fancy here. We're going to explain this once we get there. We also have some types. The difference between the types and the contracts is that contracts are for the backend and front end or clients communication. And the types is just some internal types that you're going to use throughout the course, for example, for a coordinates, geometry on the root type. So this is just so that we can have a common place for types to import. This is a type that's going to be used across multiple services, so it makes sense to define into one place. And finally, we have like a util folder. You can create any utility function, and then you can just drop them on this file. This does not have any organization whatsoever here. And this is the shared package. That's pretty much it. Then we have this tools package with this create service script. This is a small script that I have created for you to create a service. Actually, let me show you. Create a service, and then I'm going to name this service, for example, test. I'm going to you don't need to type this, I'm just showing you. If you hit enter, this is going to create you a new service here. So it's called test service, and it has the structure that you're going to use for more complex services. So it doesn't have any files, it just has the folder structure. This is so that you can just run a command and have the folder structure created for you. So this is just a utility script. So any scripts you want to create, you can drop them here on tools. And then we have here the Next.js application. You don't need to be familiar with TypeScript, but if you are a full stack engineer, you can just change this front end. Just make sure that the contracts on the TypeScript are also respected here, okay? And then last but not least, we have the makefile, which creates proto files. We're going to get to this once we get to gRPC. And then we have the very important tilt file. This is where we're going to boot up our services and create our development environment locally using Kubernetes. So again, we're going to explain tilts into these modules still. But just to give you a glimpse, this is configuration for the API gateway. And then we have here a commented one for the trip. We're going to get to that in a bit. The reason we have it commented is so that we can create a trip service very early on. And then we have the same thing for the web frontend, okay? This is the initial folder structure for the project. And I just want to mention that there is no right or wrong folder structure as long as things are easier to read and your team agrees into a standard. That's what's important. And throughout the course, we're going to use the mentality of create something simple, and then we can easily refactor it once we need that complexity. We're going to see some services using a flat architecture without folders, just a flat architecture. And then we're going to use our script to create a more of a clean layered architecture with folders and all of that. So each service can be its own service. It doesn't need to follow an exact structure. So each service can be different. That's basically what I mean. This is pretty much all for the onboarding of the code base. So before adding any code to our code base, let's understand how we can create modular and clean code to our code base. And this is not specific for microservices. This is a good set of rules that you can use for your software, be it microservices or a monorepo, whatever. This is just a set of ideas that I always teach for you to build more reusable, better testable codes. And I base these two principles. The first one is going to be the layered architecture, and then I'm going to cover the repository pattern. Both of these ideas are interlinked together. And as you know, I don't like to just tell you one way to do things. I like to give you ideas that you can start developing your taste and how you can start thinking for yourself as well. So the first idea is the layered architecture, and it's pretty simple. So the main takeaway here is that we should organize our projects into logical layers that make sense. And that's pretty much it. We're going to get to code in a bit and on the next lesson as well. But the idea is to really separate your code into logical layers that make sense. So don't abstract for no reason. For example, I give this idea because we're going to work on the web ecosystem. We're going to build the microservices through the web. We're going to create REST APIs. We're going to create gRPC, event-driven architecture as well. So All of this is on a web ecosystem. And so it makes sense to create these 3 layers at least. The first one is the transport. And what the transport means is that it is the way that we communicate with our clients. For example, in an HTTP API, the transport is going to be just the layer that we create the HTTP server. And then we have also the service layer. This is where we're going to have our business logic. I'm going to show you in a bit what the business logic really means, but it's basically where you orchestrate multiple functions into one desired outcome. For example, if you create a user, you might want to insert it into the database, and then you might also want to send an email, and you might also want to, I don't know, update some other table. So this orchestrator is, for example, a good place to be on the service. Okay. Then we have the storage. The storage is what it means. Basically, we're going to store your data somewhere. Most applications require state, so it makes sense to have a layer just for abstracting how we communicate with that storage. And this could be Postgres, could be Mongo, database, whatever, Redis. It doesn't really matter as long as we have the layer abstracted from the other ones. And also having a layered architecture means that the order actually matters. So the transport layer only knows about the service layer. We're going to see that in the codes, how we're going to inject the service into the transport and how we're going to inject the storage into the service. But the transport does not know anything about the storage or any layer below. It just knows about the layer that it communicates with, okay? Then we have these bullet points that I have added here. Some of you coming from object-oriented programming languages like Java or C# might already be familiar with these ideas, or even if you know a little bit of clean architecture. And how does the layered architecture meet these bullet points here? The first one is clear because it's a clear separation of concerns, because we have a concern for transports, a service, and a storage, for example. Again, this is just an example that we're going to use with these layers. You can add any other layer you want. Then we have single responsibility because each layer does one thing and does it well. Then we have data encapsulation. And finally, we make our code way more testable because we can just inject implementations as we wish. This is the layered architecture. Then I just want to briefly touch on the repository pattern because it's kind of is related to the layered architecture, but this focuses a little bit more on the actual way that we're going to implement this in Golang. And the idea is that we should design, or we should abstract the separation of our application business logic from the data access logic. For example, here we have the business logic, and the data access layer has two separate blocks, two separate layers. And let's consider a function that is going to update a trip. Okay, so this is something that we're going to do later on. And on this function, we're going to update the fare based on the prices of the distance that the trip is. So for example, if the trip is 100 kilometers, the price is going to change based on the distance, right? That makes sense. And this is the domain of the service, of the business logic. And imagine that we might want to create an event for the other services to listen. This is the place to do so. Then we go a level down to the data access, because once we create a trip, we're going to store it somewhere. And we might have here a MongoDB query to fetch a list of users, or a MongoDB query to update the trip or insert the trip on a table. Might also have a GraphQL mutation. This is just to show you that it doesn't matter what technology you're using, as long as your business logic does not know about it. What it's going to do is just call a function, for example, store trip, and then your data layer is going to handle that. And if all of that was too abstract for you, let me show you some concrete examples. So the code doesn't matter here. I just want to show you how we're going to compose this program here. Okay, so let's start by the data layer. You might also see this called repository. This is actually what I usually call it: data access layer, repository, storage, whatever. Here is an interface, and this is really the main part of the puzzle. If you taken the interface lesson on the advanced Go, that module, we took a look at interface, and we actually took a little bit of a look into the repository pattern, because this is the most important part of the puzzle, is the interface. Because if the service requires an interface, we can just implement anything based on this interface. In this case, we have here a SQL, an SQL user repository, which is a concrete implementation. It's a struct, and on this struct, it is an SQL because we have here the driver into the struct. And then here we have some methods. These methods just mean that we implement this interface type by type. Okay, so we have here a concrete implementation, and then we have here, actually let me change here the color, we have an abstract interface. And then I added another concrete implementation for Mongo, just to show you that you can easily replace your implementation with another one, as long as it follows the interface, because then on your service, you can just switch the concrete implementation as long as it follows this interface here. Okay, and this is just a metric to show you don't need to prepare your codes to change databases. That's something that happens rarely, but it's a good metric. That means that your code is modular. Then looking into the service, what does the service actually look like? I just have this constructor here, and I have a struct. This struct is going to have the dependency or the repository. It could be another dependency. In this case, this is the repository, just to show you that this layer depends on this layer. And then we have just here the constructor, and this is just a method to register a user. And for example, this is what I mean by business logic. We have a validation on a name, we create an entity, and then we actually call repository.createUser. But as you can see, the service does not know that the repository is actually using an SQL implementation. You don't even see here on the constructor. Where do we inject this? That is on the main, because on the main function, this is the starting point of your program. This is where we're going to inject the repository into the service constructor, and then the service constructor is going to be injected into the HTTP transport handler. And this is the whole flow that I wanted to show you, because we're going to use and abuse this pattern along the course. You can make it as simple or as complex, but this is just an idea to compose your software as small independent layers. So now that we are aware of the theory behind the clean layered architecture and the repository service, let's start getting our hands dirty and let's apply what we learned into practice. So what we're going to start doing is that we're going to create a new service. It's going to be the trip service. This is going to be one of the biggest ones that we're going to work throughout the course. It's going to have a lot of logic and a lot of transport layers. It's going to have a gRPC layer. It's going to have a RabbitMQ, and it's going to have an HTTP. In the next module, we're going to create it, and we're going to learn more about HTTP. As you have already noticed, we actually have the infrastructure needed to run the trip service that was made by me in purpose, so that we could actually start working and developing some Go codes before we start learning Kubernetes and Docker and all of that. So we have made all of that easier for you, so that we can just focus right now on implementing our trip service. We're not going to create it by hand. We're going to actually use this script, the create service, and I'm going to show you how we can do that. Let's open up our terminal and let's do a go run. So we want to run this program, which is on the tools. Then let's specify the name of the script, create service. And if you take a look at it, it receives a flag, and that flag is called name. This is the name of the service, for example, user, payments, and then the script is going to prefix this with a service at the end. So you don't need to actually prefix that with service. So what I'm going to type is name, and then I'm going to call this trip. I'm going to hit enter, And then we're going to have all of these created for us. Let me close the API gateway, and here is the folder structure. You come here to the internal, you're going to have a couple of more folders. And I haven't explained to you what these folders mean yet. And this is the place and time for me to explain them, because we're going to use them. So the first one is actually, you can actually come here to the README, and you're going to have everything there for you explain if you want to just read. But I'm going to give you a quick overview. The first one is called CMD. This is usually used in Go to have the executables or to have the entry points of the program. For example, on the API gateway, we don't have that, but you know that the main.go is the entry point, because we have here a main function, and this is what starts the HTTP server. If you were to do the same thing on the trip service, this is where it would be. For example, you could have a folder called API. This would call an API, or you could have, for example, a CLI tool for your service, and this would start the CLI. So you can see that you can have multiple executables on the CMD. And just to show you that we're actually going to execute from here, if you go to the tilt, let's scroll down to the commented codes. You can see that we can actually uncomment this for now. Let's actually uncomment, because we're going to run the trip service now. This is one of the reasons I have this commented, is so that we can run the trip service without you knowing about Tilt. So let's uncomment from here. So what you can do is select all of these cardinal signs, select them all. I'm using VS Code on Mac, so I'm selecting with commands and then D. On Windows, I'm not sure, but it should be like Control D or something like that. You can just select each of them until we reach here, and then you can just uncomment them all, or you can just do it manually as well. Just gonna have to do this once, and I think I deleted stuff that I shouldn't here, so let me just add it back. Okay, and I can also delete these comments, not going to be needed. So don't worry about what's happening here still on this module. We're gonna learn about what's on this tilt file, and we're gonna learn about the syntax that you need to know about tilt if you want to create more services of your own. But the only thing that we have specified here is that we are looking for the services / trip service. So make sure that your service is actually called trip service, like I have. Otherwise, you need to change code here and also on the Docker file. So if you know what you're doing, you can easily change this. Then you can see what I wanted to show you is that we're going to execute the main.go from CMD. So let's actually create that. This is going to be the entry point of our application. And I'm going to add this to the package main. Then going back to the other folder structures, we have here the internal is going to be where we're going to have all of the codes. All of the functions we're going to call are going to come from the internal, and the internal has a couple of other folders. The first one is the domain. This is where we're going to define interfaces and business related entities. For example, we're going to have the repository for the trip, for the fare service. Everything is going to be defined here. And then on the infrastructure, we're going to have a couple of folders inside that we're going to create throughout the course. And actually, you can just create our first one, which is going to be the repository. We're going to create a repository implementation on this video. And then we're going to also have gRPC handlers, RabbitMQ handlers. Anything that's going to handle transport is going to be also here on the infrastructure. And finally, we have the service, which is just going to have the service implementation, the actual code that communicates with the repository. And why is the service outside of the infrastructure? Because we're going to have handlers that are going to be injected with the service, and we're going to have the repository as well, which is going to be outside of the service. Okay. And actually I said final, but the last one is actually the package types. This is just a convention that you see in Go, where you have public packages inside of a package called pkg, and then I'm going to have types, and I say that I put the types inside of the package, the public package, because the types can be shared between other services and other models. We're not going to do that because we're not going to publish our services. Each service is going to consume types from a shared package. This one here, I just made this so that we have a bit of a convention. Usually in Go projects, you're going to see this defined. You could actually just delete the packages if you want and just have a folder for types, or even just a file. That is fine. Okay. Other than that, this is pretty simple, and as I mentioned on the previous video, you can just delete all of these files and create the files you want. We're going to actually create the API gateway and the driver service with a completely different structure. It's going to be a flat architecture. We're not going to have no folders. It's going to be straightforward. However, I want to make sure that the trip service is well built so that you can actually see how in production this would be done and with a more complex structure. Not only that, but the trip service is actually going to have more complex logic. It's going to have more code, so we might as well make it more modular. So enough talking, let's actually start coding. The first thing I want to start with is defining the interfaces and the types. We need to define some types for the trip. So I'm going to create trip.go. This is regarding the trip domain. We're going to also have regarding the fares. The idea behind fares is that we're going to have different types of fares depending on the distance, the price. We're going to have to calculate all of that for a single trip. So there's going to be a dependency between a trip and the fare, but to get there once we need. The first thing is that I'm going to add this to the package domain. And then let's start by creating what is a trip. So a trip is going to be a struct. Okay. And I'm going to actually call this trip model so that we don't have any conflicts with any other interface that we create. So the trip is going to have a couple of fields. The first one is going to be an ID. And the thing is, we're not going to create IDs as just strings, because later on, near the end of the course, we're going to use and store our trips in MongoDB. We're going to use that as our database. And to avoid refactoring everything, let's just start using the primitive dot object ID from Mongo. So I'm going to import from this package that we already have installed in the Go mod. So whenever you clone this project, you're going to have a lot of these packages. It's not a lot because some of these are just indirect packages, but one of them is going to be a Mongo driver. And this is what we're going to use for our IDs that Mongo uses to store its internal IDs. At the end of the day, it's going to be like a string. So that is fine for us. Then the next field is going to be the user ID. This is a string, and a trip is related to a user. So it's the one who actually made the trip, and the people that make trips here are the riders. So this is actually the rider ID. I'm going to keep it as user so that we don't add the concept of rider to the trip. Then we're going to have a status. This is going to be a string. And for now, we can actually leave this like it is. Or actually, let's create the ride fare. We're going to have two more fields. The first one is going to be the ride fare. So a trip is going to be created from a fare. Okay, we're going to see what this means. But for that, we can actually, let's create it here. Then we're going to create a new file for it, just so that I can show you side by side. But a ride fare model is going to be a struct that is going to also have an ID. So I'm just going to copy from here. And then this is also going to have the user ID. Let's add it. I'm not sure if you're going to need it, but yeah, I think we're going to do. And then we're going to have a package slug. This is the name of the package. For example, we're going to have a van package. We're going to have a luxury package or just a sedan. This is like the type of vehicle that you choose. For example, once you use Uber, you can choose the type of package that you want. This is similar to that idea. And then we're going to have the total price in cents. It's going to be a float 64. Basically, the price, the calculated price of the fare based on the distance and all of that. And then we're going to also have an expires at, which is going to be just a time.time. So for now, this is it. We're not going to have more fields as of now. We're going to add them later as we need. Let's not make things more complex than they need. Then I'm going to say that the write var is going to be of the type write var model. And for now, this is what a trip model is, okay? This is just the struct of the model that we're going to store on the database. Now, let's create the repository and the services interfaces. So this is going to be called trip repository, which is going to be an interface. And then I'm going to also create the trip service, which is going to be as well an interface. And for now, let's just create one method. Let's actually create on the repository first. It's going to be the create trip. And the create trip is going to receive the context. This is usually a good practice to the first argument to be the context. If you remember the context lesson from the advanced Go principles, you already know what I mean by adding the context here. But if you're going to communicate with any driver, any database driver, it makes sense to pass the context from the transport layer all the way down to the repository. And then we want to create a trip. So let's just send trip data for now, for example, the trip model. And these might or might not return an error. And we also want to return a trip model for now, just like so. Let me actually copy and paste this on the service. The service is going to be pretty similar, except it's not going to receive the trip, it's going to receive a var. So it's going to be based on a var. And then we're also going to return a trip model. And then last but not least, let's convert all of these structs to pointers. The reason is that we want to actually return the in-memory reference to the struct instead of just adding a copy. This is going to make sense once we get to the implementation, but you would be fine as well without adding the pointers. It's just going to help me return the actual element from the array of trips that we're going to create. So this is what the repository looks like now. Let's create the implementation or the concrete implementation for the service and the repository. So let's actually start with the repository. Let's come here and I'm going to create a file called inmem or in-memory. This is a way for me to know that this is going to be an in-memory implementation of the trip repository storage. Later on, we're going to create a new file called MongoDB. This is going to be the MongoDB implementation for the repository. So you can start seeing how we can compose our software with different layers and different implementations. And so I'm going to call this package repository because it is on the repository folder. Then let's create the actual struct that is going to have the in-memory repository stuff. So this is going to be a struct because it is an implementation. And then what we're going to have is just a slice of trips. Actually, let's make this a map for optimization purposes because we usually know the ID, so we can just access the ID of a trip from the map. We don't need to have a slice for that. And then this is going to be a pointer reference to a trip model. And for that, we need to actually call this domain.trip model. So this is a pointer to a domain.trip model. And we can do the same thing for now with the write vars. So let's just copy this up here. And instead of being a trip model, it's going to be a write var model. Something that I forgot is to create a new file. I usually like to split the domains into files. This is going to be for the write underscore var. So anything related to the vars is going to be here so that we have a separation, a better separation of the different types of models, of domains, So let me just get the write var model from here. I'm going to drop it here on the write var. Let me just save to auto import everything. And now if we go back, let me just double check if everything is correctly. So we don't have any errors here. That's nice. Here on the in-memory, we don't have errors as well. So let us create a constructor. So I just want to have a simple constructor that is going to initialize these maps as empty. So I'm going to call this in mem repository or new in mem repository. It's not going to receive anything, and it's going to return a pointer to this repository. And all we need to do is just return an instance of this with trips. And if you are using VS Code, you can actually have autocomplete for this. You just open the spacebar, you're going to see that you're going to have this option to have the make, and this is going to basically create an empty map for you. And then I'm going to do the same for the fares. There we go. Now we're not going to have any nil error if we try to access a map that does not exist. Finally, let's actually implement our interface. So if you remember, we need to implement the create trip method. So I'm going to copy this guy and I'm going to create just a func, and then I'm going to paste it so that we can have the exact signature without any error. And we need to prefix this with domain that we are already importing. Now, let's not leave this function empty, because we need to actually add just a simple logic to insert trips into our in-memory map. But the first thing I noticed is that we need to make this function a method of this struct. For that, we need to add the method signature here. So let's make this a method of this struct so that you can access the repository.fares or the trips. The first thing I want to do is let's access trips, and then I'm going to access the trip.id, and then I'm going to insert on this entry on the map. And you can see that we got an error because this actually needs to be a primitive.object.id, and I called this a string. And I don't want to make the key a primitive.object.id. I don't want to couple MongoDB with the primitive from Mongo. What we can do for now is actually convert this to a string. And that is pretty easy because you can just call .hex and you're going to have the string representation of the ID. So if you just go into the documentation, you can see that this is going to return a string. Okay. And then we can just return at the end the trip and an error, which we don't have. So we can just return nil. So with the in-memory implementation for the repository, let's now focus on the service. I'm going to create here a new file under the service folder called service. And this is going to be part of the package service. I have a typo here. There we go. And I'm going to leave this a challenge for you. Based on the previous lesson, try to implement the basic infrastructure or the basic code to have a service running and going, communicating with the in-memory repository. So I'm just going to give you another glimpse into the diagram and another refresher explanation. It doesn't matter what it's typed here. This is just another domain. It's users CRUD, create, read, update, delete. It doesn't matter. What we have is something similar. We have an interface for a trip repository, and then we have our implementation. But now we want to create the service, which is going to have this business logic. And for this, we're going to start with the trip service struct, which is going to have an dependency, which is going to be the trip repository interface. Okay. And then on the main file, we're going to inject all of these dependencies all together so that the service does not know anything about the implementation of the repository. So give it a try. It's not about the registered user, but it's more about a create trip function here. Okay, so let's get started with the service. I'm just going to call this service. I think it's fine. I'm not sure if you're going to have conflicts, but if we do, we can change them later. This is going to have one dependency, which is going to be the repo. And this is going to come from the domain.trip repository. And this here is an interface. Now I'm just going to also create a constructor to make things easier for us on the main file. And this is actually going to receive a repository, has a dependency, and then we're going to return a service struct or a pointer to a service. So let me just return service, and here we can just inject or replace the dependency with our internal one. Okay. And all of this allows us is that the main here on the CMD, let me actually just create the skeleton for this now. We can actually create an in-memory repo from the constructor that we created on the repository dot in-memory repo or new in-mem repository. And then we can have our service. I'm just going to call SVC for short. And this is going to be from the service.new service, which requires an implementation of the repository. And in this case, this is our implementation. Later on in the course, we're going to replace this with an actual MongoDB repository. For now, this is what we're going to use. And then we can just use the service, for example, create trip. Right now, this does not exist because we don't have any functions right now. Which is what we're gonna do now. So let's go to the domain here. And one thing that you might know or might notice already is that we're just gonna copy and paste from this trip service. However, nothing or nowhere is going to be a reference to a service interface. This is going to be used later on in the course because we're going to create handlers which are going to receive as a dependency, for example, like we do here. On a service, we're going to have handlers which are going to receive the service or the domain.trip service. Okay, right now I'm just calling it directly here, but later on we're going to actually use that interface. Okay, just to give you an overview of why we're not using this interface right now. So let's finish this lesson with this function, which we need to actually make this a method as well of the service. And then we need to import this from domain as well as the trip model. And here, all we're going to do is that we're going to first, or finally, we're going to call the repository .create trip. Let's pass in the context from whomever called the service. And then we need to send a trip. For that, let's actually create here a domain.trip model. And then we need to add an ID. The ID is going to be, I don't know, let's create something. We actually need to make this a primitive.object ID. So what we can do is create a new, call this primitive.new object ID. And the reason that we're just creating this manually is that later on we're going to have Mongo auto-generate these IDs for us. So we need to do this manually, otherwise we might have an error once we get to the in-memory, because we actually require an ID to be created. So this line here is important for now. Later on, we can assume that the ID is going to be always created because it is going to be handled by Mongo. Then we need to have a user ID. We can just leave all of these fields empty for now because we're not going to use them. And even the right fare, we can just pass the fare that we got from the parent. And now that I'm looking at it, we can actually use the fare to get the user ID. So we can just do this. This is a nice way to get it. And I'm also seeing that we have here an error, which basically means that this is a pointer. However, we are expecting this to not be a pointer. What I'm actually going to do is that I'm going to just make this a pointer. So on the trip model here on the domain, let's open up trip, and I'm going to convert this to a pointer again, so that we don't need to do any pointer dereference here. And finally, to make things complete, I'm going to add the status to be pending so that we have something added here. Okay. Now we have everything created. Let's go to the main, and we can see that we can actually call the create trip now. Let's pass in a context. So I'm going to create a context up here, which can be just the context.backgrounds, which we can just pass to this function. And then we need a fare to create a trip. So let's create a dummy fare. It's going to be a pointer. So let's make this domain dot ride fare model. This is going to have an ID, which we can just actually you can ignore the ID for now. Let's just send the user ID as 42 because this is the only thing we are using right now. This is just for demonstration purposes because the main is not going to be the one calling the create strip. It's going to be a handler or a gRPC handler on the infrastructure later on. But for now, I just want to show you that you can compose all of these layers here on the main, which is where we are actually going to do that. So this is pretty much it. Let's run our project, open up the terminal, and let's do tilt up. And what we're going to see is that this is just going to run these main scripts. It's not going to do much. Actually, we could add some logging here, but let me see if everything runs first. So let's open tilt. And let's go to details. And here we have our trip service. It has a warning. So something is actually wrong here. So I think what's happening here is that the container is always restarting. So the program finishes and then it always restarts because this is what we have defined in our tilt. So the first thing we want to see is, do we have any error? And let's also see what is the trip. So I'm going to handle this function. So I'm just going to see if the error is different than nil. If it is, we can just log it. Not too interested in learning too much error handling here. And then I want to also see what is actually the value of trip. The last thing is that we need to make this program run infinitely because in our tilt file, when the program exits, here we have Docker builds with restarts, and this is a small utility function that I load from the tilt. And what this is going to do is that this is going to restart the Docker container if it finishes or if it crashes. In our case, it's going to finish because the program is ended. So what we want to do is to have a temporary way to listen or to keep the program running. One way we can do this is by using a select. However, this is going to cause a deadlock issue. It's not going to be an issue because we're not going to use the trip service for now. However, if you want to avoid warnings on your tilt file, what we can do is just a for, and then we're going to do a time.sleep for example, a second. So we can just do this. And then I'm just going to add here a comment that this is temporary. Keep listening or keep the program running for now. Okay. And then going back to the tilt file, you can actually see that we have everything green, and this is the printed statements that we got from this print line. So what we have here is that this is the ID, then this is the ID of the user, the status, which is pending, and this is a pointer reference to the fare. And so this pretty much wraps what we need to do for this chapter to apply the repository and the clean layered architecture. And hopefully this hasn't been too long, but this is a very important and fundamental module for us to do this, because later on we're going to build upon what we have done just right now. So it's going to make our lives easier in the future. And this is a very nice way for you to learn on how to build modular and testable applications. But then on the next module, we're going to take a look at the API Gateway Service, what it is, we're going to improve it, and I just wanted to get your hands dirty on this chapter with the trip service. So now that we already started working in the project, we did create a trip service and we kind of onboarded ourselves into the codebase. I want to demystify a little bit everything behind the scenes when we run Tilt up. So everything regarding the local development flow, I want to kind of explain to you what's behind the scenes. So by now you know that we're using Kubernetes. We are creating a local Kubernetes cluster. I'm using Minikube to do that. And that we, in our code base, we have here all the infrastructure to basically have Kubernetes. Here are the deployments, here are the services and all of that. And we have this file, the tilts, which we used to start the project. And this is what I want to explain. Why are we using tilts? And also, why are we using Kubernetes to develop these projects? And to give you a better overview of that, let's consider not using tilt. Let's consider how would be the normal flow. So imagine that we have some codes. We can actually open the project here side by side, just like so. Let me actually come here. For example, we imagine we are developing on the API gateway. Let's consider, I'm going to delete this line just to show you, and I would save this. And what would happen is that there's no auto restart for us, there's no hot reloading, there's no service that is going to automatically restart our API gateway. What you would need to do is that we need to do a Docker build. In this case, for the API gateway, we need to upload to remote Docker registry or locally in this case, and then our Kubernetes cluster would need to pull the image. So all of these would need to be manually. So you'd have to go to the terminal, cancel the API gateway service, do a Docker build, push it, or if you're not using a local registry, you can just pull the image from Kubernetes. So there's more steps hidden behind this, but this is what you need to do. Now imagine if you have more services, because we're going to start working with 3 to 4 services running at the same time. And you need to do these for all of those services, and you might not even know what changes you did during your development, because sometimes you add changes to the gateway, then you add changes to the trip service and the shared folder. So you can see how this is leading to a tool to help us automate everything. And this is where Tilt comes in. Basically, as you already saw, we have a centralized place for the logs. Let me actually start the project and show you what that looks like if you haven't already. So Tilt's up. I'm going to open the browser editor here, and you can see that we have kind of a centralized place to see all of the logs from all of the service. And this is very nice because you can just see logs from the API gateway, logs from the trip service. Right now, this is just building the Docker image. But once we start getting very chatty services, we're going to have services communicating with one another. This is going to be very nice to see everything happening here. Okay, this is one of the first advantages. And then we're going to have local code live sync reload. This is for me one of the best sellers because we're going to reload our projects, deploy everything without us having to do anything. Basically, what I'm going to do, and actually I can just show you. I'm not sure why I closed this. Let me add it here so that you can see everything happening. I'm going to clear the logs, and I'm going to revert and add this log. And once I save, you're going to see that the API gateway is going to restart automatically. You can see we got a trigger, it restarted, and there we go. It is restarted successfully. And this is the magic that I wanted to achieve with Tilt. Then we also have configuration reload. So if you're going to update your Kubernetes configuration, for example, I'm going to add 2 replicas, 3 replicas. What this means is that you're going to increase the amount of instances of this service. Then this is going to automatically reload for us, just like the code. And finally, another cool feature is that we're going to have port forwards. So you don't need to manually create port forward once you're creating a server. Okay. So hopefully now you got kind of the gist why we're using Tilt to help us develop Kubernetes locally and how hard would it be to just do it manually. There's other tools that do this. One of which it's called Scaffold. It's a project from Google. I think it's somewhat of an older project. Tilt is a bit more recent. But when I started working on this project for the course, I actually started with Scaffold, but then I decided to go with Tilt because Tilt is easier to teach and has the same features and you don't have to write that many configuration as I did with Scaffold, which makes it even easier to teach. So this is another alternative. If you already worked with Scaffold, it's completely fine, as long as you achieve the same results. Then let me just quickly give you an overview of why we are using Kubernetes. I'm going to leave this article below if you want to read it. It's from the official documentation, but I kind of distilled the reasons of why usually in production we use Kubernetes. So the first really nice thing we get is that it's highly available and we get scalability out of the box. We got auto scaling. Imagine that I was going to set the replicas to scale to 5. What that would mean is that if we have more traffic to our server, we are going to have more servers booting up. For example, consider this example where we have one instance of the trip service, so just one server. Now, how is the easiest way to increase performance for our users that are going to make requests to our servers? So if we have a lot of traffic, we're going to have some slowdown from the trip. We could, of course, scale our machines to have bigger and better machines. However, there's how much you can scale, of course. And the second best way to do is to scale into multiple instances. Usually, you'd have to do this manually. Most cloud providers these days do this for us. However, with Kubernetes, it already has auto scaling for us as well. So that is very good because you don't have to worry about that. You don't have to wake up in the middle of the night to scale up your servers. And when I say scale up, it also means scaling down so that you save some resources once you don't need it. And then, of course, we have load balancing, which already goes hand with auto scaling. You need to load balance to these servers. And self-healing is also very important because if one of these instances dies, the Kubernetes engine is going to redirect to a healthy server. Then we have service discovery and networking. Once you have multiple services, you need a way for them to communicate with one another. You need a way for them to know what are the servers. And this is easy enough when you have two services with just one instance. But what happens when you have multiple instances of the same server? How do you know who to communicate? All of that. There's tools built for this, but Kubernetes comes with a solution out of the box that we don't need to worry about any of this. So that is nice, which also means that we have consistency across all of the environments. Then, last but not least, we have a simplified deployment and somewhat of management because some people might like the declarative nature of this configuration, others might not. But reality is that it's somewhat easier than to have manual configuration. Then we have rolling updates and rollbacks with zero downtime. What this means is that if we release a new version of a service, if this is going to be version 1, we can have zero downtime for our users once we deploy this new version because we need to delete or kill these older versions to replace with these new ones. And Kubernetes handles that for us as well. So these are just some of the reasons that we are going to use Kubernetes for the project. And another one, which is actually a big one, is that Kubernetes is really strong in the market. So if you're looking for a job or something like that, Kubernetes is a very good asset for you to have in your portfolio. So it's always worth it to learn if you're going to do any sort of backend engineering or DevOps related work. So let's understand, why do we need an API gateway for our projects, and what is the role of the API gateway? How can we build the do's and the don'ts of an API gateway? So first, you might have already seen that one of the services is called API gateway, and this is no normal service, you could say. And the reason is that this is going to manage all of the other services from the outside world. And by looking at this diagram, it's the best way to understand what I meant. The API gateway is only concerned from managing the access from the outside world. And how does this translate into practical terms? First, the outside world for us is going to be our React front-end application. We could have a mobile application, we could have multiple clients, and this is what I mean by client, is the consumer of our backend, of our system. But the API gateway is going to act as a single entry for all of these clients. Right now, we just have these front ends, but in a production application like Uber, you might have a mobile application, a desktop application. All of these are clients, and the API can give a personalized experience for these clients. For example, a mobile app might want to use GraphQL, or a red desktop application might just use HTTP REST. How we're going to actually do. And why do we have these middlemen inside of the system? The reason for that is that we don't want to expose our internal services to the outside world. We don't want to expose the trip, the driver, or the payment service to clients. What would this mean is that they would have to know about this service in the first place, which is already a security concern. So by letting and exposing all of these services to the outside world, let's imagine that we would expose them. This would create a lot of backdoors for our application. Not only that, the users would have to connect directly to each service. So you'd have to keep track of all of the addresses, all of that, knowing how to communicate between them. And this is what we don't want to achieve, hence the gateway. And so the API gateway is going to read the request, is going to parse it, is going to call the right service. For example, if we want to get a trip, the user is going to call via HTTP, and then the API gateway is going to go to the right service and is going to initiate the gRPC connection and is going to call this service. So everything is abstracted for us from the outside world. As well as the API gateway can call multiple services. Imagine that you might want to call the service or the trip service, which just gets the trip data, and then we might want to call another service with the response of this service, for example, the driver. We're not going to do much of this because, as I'm going to explain in a bit, this is kind of a drawback or kind of a don't do in a gateway, but we're going to see this in a bit. And finally, an API gateway is especially relevant for us because we're using Kubernetes. And the reason for that is that Kubernetes already handles the inter-service communication or the internal service-to-service communication. So we don't need to worry about that. However, outside of the cluster, when you're talking about outside communication, we need to have a single point of entry for all of the services. And we can easily achieve this by exposing this, and this being the only service exposed. Now, once we're adding an API gateway, there's a couple of things we need to worry about. The first one is that it adds an increased response time because we're adding an additional network hoop to the API gateway. Basically, this makes sense because we're adding an extra connection. Oops, I have the wrong marker. Basically, we're adding an extra loophole to get to a specific service. So we need to make an extra call. However, for most applications and for us, the cost of this extra round trip is actually irrelevant. And I mean, we're going to use Go for these services. It's going to be super fast either way. But even then, if we have all of these services inside the same cluster in Kubernetes, we don't need to basically worry too much about that. But one thing we need to worry about is call aggregation. This is kind of a good thing and a bad thing because you can make multiple calls to multiple services, so you can kind of aggregate a response to the user. However, this is kind of a red flag because usually means that you're adding business logic into the API gateway, and this is something you don't want to do. For us, we're not going to do much of this. We don't need to, but if I would need to add some business logic or some call aggregation to multiple services, I would not be as worried because the alternative solution usually means more complexity, adding a new service or something like that. So don't worry too much if you do some call aggregation. Just be aware that these might lead to increased response times or just adding business logic to the gateway, which is not the role for it. And the last thing I want to talk about is the third-party vendors. So there is a huge market for API gateways out there. And for our case, we don't need any complexity from these usually feature-bloated solutions. We don't need it because we're just going to expose our service to the Kubernetes load balancer. So I'm just telling you these because you might have to advocate to the company you work at to create an API gateway, and usually it might or might not be a good idea to use a third party. So this is kind of an investigation you need to do yourself. For most applications, you don't need to, especially if you're just going to do some sort of a load balancer or an aggregate caller to multiple services. You usually don't need this kind of stuff. But a couple of years ago, there was kind of the big boom of the APIs. Most businesses discovered that if they exposed an API to the outside world, they would make more revenue. And what's ended up happening is that there was a lot of API gateway solutions out there in the market, and they usually sell you a lot of features to make it look like they're secure, and they usually are secure, but you don't usually need those features, and you're just going to add a dependency lock to your application that you don't need. So this is just an aside if you're working on a team and you are some sort of lead that needs to make a decision. Take a look at third-party vendors, see if it's worth it or not, and yeah. Okay, so going back to the code, let's go back to our API gateway. Now that we know what an API gateway is and its role, let's first start by improving our HTTP server, because here we have a very simple HTTP server listening on these ports, and then we have these endpoints. Let's start by creating and then improving, or in this case, let's start by improving our HTTP server setup, because currently we're using the default MUX. And by the way, you might hear the word MUX a lot in Go, and what MUX means is that it is an HTTP request multiplexer. And it's good to know because most of the times you're going to see MUX instead of like HTTP server. And even in the Go code, you're going to see, for example, http.mux. Here you're going to have the default serve MUX, and what MUX means is HTTP request multiplexer. You don't need to know what MUX means word by word. Just know that MUX is a router. In the context of an HTTP API, it means that it's going to help to route the request to the right handler. And right now what we have been doing is that we're using the default MUX from Go. This is the default way of creating an HTTP server. It's very fast, very simple. However, we want to create our own MUX, or in this case, we're going to create a new instance of http.newServer or newServMux. This is going to provide better isolation for your API routes. This is usually good practice to do. And also, it makes it easier to add middlewares to our API gateway. Then all we need to do is just replace this HTTP here with MUX. The output is the same. It's an http.servMux, and there is a lot to say regarding creating HTTP's APIs with Go. I have made complete 70 plus hour course on this. And if you are on a self-made engineer platform, you get access to that course for free on the classroom. So if that is something that you're interested, check it out, because I'm not going to go very deep into how to build HTTP APIs on this course. That would make this course way bigger. But for this project, you don't need to build a very complex API. So what I'm going to teach is more than enough. Then one last thing I'm going to do is that I'm going to create a server. This is going to be a manual creation of our server. It's going to be a pointer to an http.server. And what this is going to allow us is that we can specify first the HTTP address that we already did, and then we're going to have a handler which is going to be our MUX. Why this is cool is that if you want to add a library, because By the way, we're not going to add any package, any HTTP package. We're going to keep it standard. But if you want, you can just call the constructor. For example, you can call Gorilla Max, you can call she, anything. And then all you need to do is replace here the handler. And then we just need to call the server dot listen and serve. And these might or might not return an error. So it's always a good practice to handle this, because later on we're going to add graceful shutdown, which is going to be even more important for our microservices, because we have local reloads or live reloads once we make a change. So that is very important that we gracefully shut down our servers so that we don't have a port collision or something like that. But more on that later. And finally, I'm just going to log here print f if there was an error, HTTP server error, and then the error from here. And we can just add here a missing comma, and that's pretty much it. Let's first see how the server is running, if it runs, if everything is okay. And then we're going to work on creating our first endpoint for creating a trip preview. So let me just do tilt up again. Let me open up Tilt and see if everything is okay. I want to see the API gateway starting and then get the message. There we go, starting API gateway. And then if for some reason we change code here, let me do some code change. Let me add, let me just close this. Let me add a space or remove a space, save it. And then let me see if it got a change and started the API gateway. Good, okay. So with that basic setup out of the way, let's now focus on creating our first handler or endpoint. You might hear me use those two terms, but we want to create a handler or a place that the front end can call to create our first endpoint, which is going to be the trip preview. It's going to be something around /trip/preview. And how do we know that this is the right string? This is something important, that you have the same exact string as I have here, because if you are counting on using the web application is calling this right string here. It's making a post request, an HTTP post request to this exact string. And how do you know that this is the right one? If you want to debug on your side, I mean, there's not much to go wrong, because you're just going to create 4 handlers by the end of the course. So there's not much you can fail there. But if you want to debug a little bit, you can go into the web folder inside of the source. And here we have the contracts.ts, just like we do on the backend. Here we actually have this commented out, which is an enum with all of the handlers that we're going to create on the backend. So the front end expects the backend to have these guys created exactly as they are. So you can just copy the string from here, and then there's no way that you're going to mistype this. Okay, so that is very important. Otherwise, your front end is going to throw a 404 once you click on the map to create a trip. If you're, of course, using the web. If you're just using Postman or any HTTP program out there to make calls to your backend manually, then you don't need to worry about that. So you can go your own route if you want. Now we can just delete this boilerplate code. This is what I call a handler or a handler func for the mux. If you look at the definition for the handle func, you can see that it receives a handler, and this is a very important interface when you're talking about the net HTTP package. I covered that in the backend engineering course, but for now we just make sure that we create a function that has this exact signature. We can actually just copy, I'm just gonna copy this guy, or I'm gonna just get this, and we can delete all of the rest of the code. Why I'm doing this? Because we're gonna create a new file called http.go. So anything related to our HTTP handlers are going to live in a separate file on the same package, so that you can just directly import it and have a better separation of our code base. And then let me just paste this guy. I'm going to call this handle trip preview. And we can just save so that we import everything from net HTTP And now I'm going to replace what we had with this function. We don't have any errors. That's awesome. Now, there's a couple of things we need to do to make these work. I'm just going to show you on the front end. You don't need to follow me here. I just want to show you what the front end is doing so that you can understand what we need to do on the back end. So if you go back to, when is it? I think it's components, and then it's the rider map. If you go here to something similar to this one, let me just quickly search this one. So here we have a function that is going to call our endpoint, our preview endpoint. And this guy is going to make a post request, an HTTP post request with some payloads. So we need to expect to parse this payload from the front end. And how does this payload look like? It's this interface here. You can already see that it receives a user ID. This is the user that is making the request ID. And then we have the pickup location and the destination, where we want to go and where we start, basically. Then on the backend, we're going to do some sort of calculation on the trip service. So we're going to call the trip service at some sort of time. So let me just add here to do call trip service. Along the course, we're going to call with gRPC, just to give you some hints. We're going to do a gRPC call to the trip service, and the trip service is going to handle this calculation. It's going to handle this algorithm to calculate the price, the distance from the pickup to the destination, and all of that good stuff. But right now, we're just worried about creating the basic infrastructure for that to happen later on. And yeah, I just wanted to show you that we need to have this interface parsed on the backend. We're going to expect to receive this, and to do that, we can just create a variable here, which is going to be requests body, for example. And let me create a struct to hold that value once we get it from the requests body. So this is going to be preview trip request, for example. I'm going to create a new file called types.go because I can expect to create multiple types like this in the future. This is just going to be a simple struct to hold the types that the front end is going to send on a payload. And it's going to look like exactly what we saw, the user ID, which is going to be a string. Then we're going to have the pickup location and the destination. Both of these, we already actually have the types created. If you remember from the template, we have this folder called shared. And inside of here, we have some types already created for us. One of them are the coordinates, which the front end is using. So we can just copy and then just call types and make sure that you're calling the, let me do this again, that you're calling the shared types, because there's a golang package called types, it seems. So I'll just make sure that we call the shared types. Then let me just copy and paste down below. The last thing we need to do for this struct is to actually add JSON marshalling and unmarshalling. This is something that it's very specific to Go, because Go uses uppercase letters for public words or public methods. For example, here we're using a U and a P and R uppercase. However, most languages like JavaScript, they don't have a private and public way of doing this. They use actually a private and public keywords. And one of the reasons we do this JSON marshalling and unmarshalling automatically, it's because of that. And what does this mean in simple terms is that the front end, let me just type this out. This means that the front end is going to send this. However, on our backend side, we're going to consume our struct like this, for example, preview request.pickup instead of pickup with the lower P, okay? And what it means behind the scenes in simple terms is that we're going to receive this and Go is going to automatically convert to destination with uppercase, okay? So let's go back to HTTP. And now let's finally decode the payload body from the type. So let's call JSON, or actually we're going to receive an error if we have one, because otherwise we're not going to receive any output value. It's going to directly insert into this type. Hence why we have already created it here. If you are already familiar with this, you know what you're seeing. Let me get the IO reader, which for us is going to be the body. And then I'm just going to call decode. And here important, don't forget to add a pointer to the request body. If you don't add the pointer, sometimes it's hard to kind of debug why you're getting this error. So again, double check that you have a pointer here. Then let's handle the error. If it's different than nil, let me first return so that I don't forget. And then I'm going to introduce you to http.error, which is going to basically return, it's going to write an error to the response writer, which in this case, we're going to use our response writer. And then this expects a string, which is going to be the error string. So you can write anything you want here. For example, failed to parse JSON data. And here you're going to return an HTTP code, but it's basically a standard code that clients are usually expecting to do. For example, there's status 200 for OK or success, and there's, for example, 404 for not found. So you probably know 404 because it's very famous. One trick I can give you is use the HTTP codes from Go. So if you type HTTP dots, you have access to like an enum with all of the codes. For example, we're going to use the status bad request. That's what it's usually used if the payload is incorrect, which is the 400. And here you can see all of the codes with a name. This makes the code more declarative on your site, and I think it reads better. So you can see that you're returning an error. Here is the message, and it's a bad request. Now that we have our request body, so if the request body is correctly sent, we're going to go next to the next slide. But before that, let me actually do something here, which is I want to make sure that the post method, or the method that the frontend is going to send, it's going to be of type http.post or method post. This line basically means that anything that is different than a post, it's not going to be handled by this handler. In more recent versions of Go, you can just add post here and it's going to work fine. You want to see this working? Let's actually do this. Let me save, because we are actually using Go.23. This is a version that allows for us to add here the names. I'm going to add post here, and I'm going to remove this line. Let's save, and I'm gonna actually just gonna return, or actually let me just log something so that I know that I have called this endpoint success. Then I'm gonna do tilt up. I'm gonna wait for the API gateway service to be green, and then I'm gonna, for example, currently we cannot use the web application to show you this because we don't have the WebSocket connection. So what's gonna happen right now is that I click I need the rights, it's not going to work because we haven't reached that point yet. On next modules we're going to implement the WebSockets. But for now, the way you can test this is, for example, with Postman. So I'm using this program to make HTTP requests. You should already be familiar with something like this. And I'm going to make a request to our API gateway, which is at the, if you have in doubt, which is the address. You can see here on Tilt, which is the 8081 at localhost. I'm going to make requests to there for the /script/preview. And if, for example, I use a GET request, you're going to see that you're going to have an error. By default, our Mux is going to handle this. That's what I meant, that it's a multiplexer router. It's going to handle this for us. And that's how you can actually use the post here on a string. So later versions of Go don't allow this. That's why I wanted to actually show you that you can, if you have an older version of Go, you might see this on older code bases, is that sometimes they do a request.method. It's different than, for example, post. Okay. So I just wanted to give you this bit of information because you might see this on later code bases. And since we're here, let's actually call post. Let's go to raw and then JSON, and let's send in, for example, something empty here. This is going to work because we're not have any validations. Although we're not sending the exact payload, it still works because the unmarshalling here does not do any validation. It does not check if we have this type. We know it's working because if you go to the web browser, we're going to see that we have the success log here. So it's reaching this point of the function. Okay, I have just shut down Tilt. We don't need to have the server running for now. And let's finish up the setup for the handle preview trip. The next thing is that I'm going to close the body. So this is important. If you open the body to do some unmarshalling, then you have to close it, because every method that has close in Go, you should call this after, so that we can clean some resources. Now, you saw that we could call these methods without a user ID. We didn't have any validation. So let's make some simple validation. You can improve this if you want, as you want. Right now, I'm just going to do request body.user_ID. If the user ID is different than empty, or if there's no user ID, I'm going to return an error. In this case, I'm just going to return empty. And I'm going to copy the http.error. And I'm going to, instead of sending this error code or this error string, I'm going to say user ID is required. And the code could actually be a by request. I think that's the right one for this use case. And finally, let's actually send to the user a success error code if he reaches these parts. Right now, we don't have functionality, because the functionality is going to be on a different service. So all we need to do here is just tell the user that, or in this case, we need to write to the HTTP writer that the response has been successful by sending an HTTP status code that it's a successful one. What I usually do is I like to create a new file for this. And what we might end up doing later on is to actually create or moving this functionality to a shared package, because the trip service is going to also have an HTTP server for practice later on. And I say for practice because we're going to deprecate this HTTP server afterwards with gRPC. We're going to gradually get there so that you can also have some experience creating an HTTP server if you want. But the function I want to create is called write_JSON. And it's going to make sense in a bit why I want to create a function for this. The arguments for this are going to be a handler, or in this case, just the writer part. So you can just copy the writer of the handler. I'm kind of lazy, so I'm just copying it. Then I'm just going to save to get the HTTP import here. Then the second argument is the status, which, as you saw, it was an integer. And then the last one is going to be data, which could be anything. And it's going to return an error if there is one, because we're going to call JSON.newEncoder. So instead of decoding, like we did here, we're gonna, instead of decode, we're going to encode here. And we're gonna receive a writer, which is going to be our io.writer, which for us is the HTTP response writer. Then I'm just gonna call encode, so very similar to what we have done, and I'm gonna send the data. So that's why we need to return an error, because this might fail. Then we need to do two things here before returning. The first one is to set the header of the contents type to be application JSON. So let's just call header.set contents type. Now note this is uppercase, this is as it needs to be. And then we're gonna just send application/JSON. If you want, you can just go to the course resources and copy this file entirely. You don't need to type as I go. As long as you're learning what's happening behind the scenes, that's fine. You can code it afterwards. Then the second thing is just to write the status to the header. So like we did on the error, we're going to do this manually, because Go does, on this function, it does it for us. However, on our function, we need to write the status code, so it accepts anything we want to send it. So all we need to do here is just write JSON, send our writer the status code we want. For example, I'm going to use the created, because it is created a resource, it has created a trip, and the data could be anything for now. Later on, we're going to use the payload or the output of the trip service to actually populate the response. Right now, I'm just going to send OK. And this should be pretty much it for this service. And actually, I just saw here as I was skimming the code, this expression is wrong. It should be equal to empty. We would get this error otherwise. Now let's actually go back to the Postman and let's try to run this. So I'm gonna hit send, and we should have this error, which the user ID is required. We're not sending anything, so it is nice. We landed here on our simple validation. If you want, you can validate the other fields. I wouldn't do that right now because it would add a little bit more complexity for your end. But if you have the time, add, for example, some validation for the coordinates. That's up to you if you want. Other than that, let's actually see if this works with the proper user ID. Again, we're not even testing what kind of user ID is, if this exists or not. That's not the point for this course. Let's hit send, and you can see that we have OK. So that is pretty much all I wanted to teach you on this lesson. It's just a fundamental thing to know about Go and HTTP servers. On the next one, I'm going to give you some sort of an exercise for you to practice creating a server on a trip. I just want to show you one last thing before I go, which is we actually have a contract here. We have an HTTP for a response. You can see here that we have an API response. So this is a way to structurize what the front end can expect the backend to send. So I'm going to copy this. You can see that it expects a data, which could be anything or an error. So this is what the front end is expecting, and this is how the front end handles the errors and receives data. So whenever you call write JSON, we want to return a contract.api response. For now, let me just call response here, and it's going to be empty because if we want to return, for example, the trip preview, we don't currently have it because it's coming from the trip service. Right now, we could still keep the OK. And if you go back, for example, Postman and just hit send, you can see that the same thing happens, but we have a data property here. Later on, we're going to have an object here with the preview, the route, and all of those coordinates. All right, so we have come to an end of this 3-hour-long huge video that we have just watched. And really, I want to thank you because it's not everyone that can watch a video, an educational video of this long. So thank you for your commitment and your persistence through learning really these concepts. It's really something. And then I just want to give you a state overview of where we are in the course and how and what you can expect if you decide to enroll. So basically we have left off here and we have done an introduction. I have taught you about the microservice architecture design, which is really important. I know it's a lot of theory in the start, but it is really important for the rest of the modules. And then we started with our development environments. We started to learn what are the tools that we're going to use. And then on this module, the API gateway and HTTP servers, this is really more how we start the gateway server. And then I teach you about REST APIs. By the way, there's a huge video like this one on my channel where you can watch the backend engineering course, which is very similar to what we're doing here on the API gateway. So if you want, you can watch that. Or if you want to enroll, this is what you can expect. So we're going to start off with an exercise where I'm going to challenge you. And then we're going to move into something very interesting, which is we're going to start working with the map and actually doing the preview of the map. Very interesting module here. So this is what you can expect for this module, and then we're going to work through WebSockets, service-to-service communication with gRPC. So you can see that this is just the tip of the iceberg that you have just seen. There's all of these modules still left. So if this is something that interests you, click the first link below. This course has been in the making for almost a year, so I really appreciate all of the support and hopefully you have enjoyed it. And again, thank you so much.